Dobro jutro in dobrodošli na drugem dnevu konference HEK.SI. Še enkrat bi vas rada pozvala k dobrodelnosti, kot smo že včeraj omenili, zbiramo za družino, ki jih je tudi ta COVID situacija zelo prizadela, tako da kdor lahko bi vas prosili za vaš prispevek na 1919 z besedilom Prijatelj 5. So, let me continue in English. So, good morning and welcome everyone to the second day of hacking conference. I would like to welcome and thanks to all our speakers, to all our sponsors, participants, and Andrei Rakar. We are very grateful that you joined the conference as our moderator. So I would also like to remind you that later we will put to the chat the link for the survey, and I would like to ask you to fulfill the form. I wish you a successful day and of the conference, and of course a lot of interesting presentations. So Andrei, the floor is yours. Thank you.
Thank you. Hello everybody. So don't forget, today we finish the conference with a round table. So you are invited to join. So we welcome back Pete Finnigan, our expert for Oracle security. Today he has another interesting talk for us titled Oracle Database Password Security Deep Dive. Pete, the floor is yours. Microphone. Yeah.
Thank you. Yeah, I did it. And I'll share my screen as well. Okay, let me just find the right one.
It's working fine.
Okay, great. Okay, good morning, everybody. So we're going to talk today about Oracle passwords. You might ask why we need to know about Oracle passwords. Well, we want to enforce strong passwords in the Oracle database for all of the users. And to do that, we need to create password profiles within the database. These enforce the rules for strong passwords. So at a high level for a profile, it includes things like the lifetime, whether the password can be reused or not. It includes a grace time. So when the password expires, then you've got, say, 7 days until you have to reset it and it stops working. It also includes the rules for the complexity of the password. So how strong the password is. So its length is obviously important. The character set, so whether it's ASCII, whether it's uppercase, lowercase, whether it is including numbers, whether it's including special characters and so on. So to design these profiles, we need to understand a little bit about passwords. So that's what I want to talk about today. So a little bit about me, in case anybody wasn't on my talk yesterday. I only do Oracle security. So anything to do with the Oracle database and securing data within the Oracle database. So we're going to talk about the problem, which I've defined a little bit already. I'm going to talk about the password algorithms that exist in the database. Notice the S on the end of algorithm. So there are multiple password algorithms in the Oracle database. We'll talk about cracking passwords, the security passwords, and obviously we'll finish with the profile, because the whole goal of understanding strong passwords is that we want to design a password profile where we can enforce a strong password, and we know that that password wouldn't be cracked within the lifetime of the password that we've designed. So at a high level, if you want to attack an Oracle database, there are literally two very, very high level things you can do. One is you get an account and a password and you log in. Obviously, this is easy. You just provide the connection details, you log in, you start to look around and see what you can do with the privileges of the user you've got. Maybe if you're clever, you can then escalate to a different user. Maybe you can escalate your own rights. And obviously the goal would probably be to steal data from the database. How do you get the password? Well, you can be given it because you're an employee. Maybe you're a DBA, maybe you're a developer, maybe you're a business user, and you happen to understand that the password and the username you got for the application is actually an Oracle database username and password. This happens quite often. And you can then connect directly with an Oracle client, download it from Oracle, it's free, put it on your PC and connect. So if you cannot connect to the database with a username and password, the only other way is to start exploiting applications. So looking for vulnerabilities in the application screens, looking for SQL injection and all types of attacks. So for a direct database connection, we obviously need a direct pipe to the database. We need to be able to connect to the database. So we need open routing, or at least controlled routing within the organization that allows us to get to the database. We need the network details. So we can't connect unless we know the IP address, the port number. We need the SID or the service name. So it depends on how the DBA set it up, whether it's a SID or a service name. And of course, we need the username and password. Often we can locate all of the above except the username and password. In fact, lots of companies just simply deploy this information to every desktop computer in a file called TNS names. So it's easy for anybody to gain this knowledge and understand that the only thing that they then need is a username and password. In most sites where I do security audits, then you could easily guess a password. So I've done password cracking for 20 years on people's databases, and you still find passwords in every single database where the password is set to the username, or the password is incredibly weak, or the password is a default. So easy to get a password to connect. So there are, as I said, more than one algorithm in the Oracle database. So from starting with Oracle 6, when Oracle added the first sort of proper algorithm, the DES algorithm, this was added and this continued until the end of 10G, when the SHA-1 algorithm was added. So Oracle in 11G release 1 added case-sensitive passwords, and they changed the algorithm. I'll talk about the algorithms in a minute. They changed the algorithm. So from 11G release 1, we had 2 database password algorithms and 2 password hashes stored in the database. From 12.101, we also then got a HTTP digest. So Oracle supports web-based applications such as XDB or Portal or Apex. And in the past, it was just a standard .ht access file, HT password file. Oracle moved this into the database, and it's now in the core user table of the database. From 12.102, Oracle added SHA-2. So they changed the SHA-1 to SHA-2. It's not exactly SHA-2, but I'll talk about that in a minute. So there are 4 core algorithms in the database, and you can see these in the slide. So I've selected out the password details for a particular user, DBSNMP in this case. You can see the DES algorithm, the shortest one. You can see the SHA-1, it starts with an S colon. You can see the HTTP digest, it starts with a H colon. And you can see the SHA-2, it starts with a T colon. So we have lots of possible algorithms to play with. So if we just talk about each algorithm, first of all, so the DES algorithm, the first one, it's weak in today's sense because it's DES and the key length is too short, so 56 bits. And actually, if you get rid of the parity bits and so on, it's actually shorter than that. It uses an encryption algorithm, and the guy called Bob Baldwin designed this. And Bob Baldwin was the guy who designed the authentication for Windows NT, for VMS. If you look at those, they're quite similar to Oracle, not exactly the same. Bob Baldwin did describe this on Usenet in 1993, but actually, if you go and look at that post, I haven't actually checked that link for a long time to see if it's still there. But if you look at that post, you'll see that it's actually slightly incorrect. He's described it wrongly. I don't think he did it deliberately. I just think he maybe forgot what he did because it was probably 10 years earlier when he designed it. So the way it works is you take the username and the password and concatenate them together. So the username becomes a salt for the password. So if you have 2 different users with the same password, because it's concatenated with the username, they're not going to get the same password hash. So it's salted. So you then Unicode the string. So basically you take each character and put a 0 between it. So if the password was sys, it would be S0, Y0, S0. You then encrypt it using DES in CBC mode and use the key that's on the slide, 1, 2, 3, 4, 5, 6, 7, and so on. And you encrypt it in blocks of 8 bytes at a time. And you use CBC. When you've encrypted the first block, you then XOR the results with the next clear text block and do it again. And you carry on until you've done the whole password and username. When you've finished, you then take the last input vector, not the last result. So the last result of XORing the previous result with the clear text, and you use that as an encryption key and start again. So this is why it can use encryption, because it's not reversible, because it's encrypted twice. It's a reasonable algorithm, but the key length is too short. SHA-1 was added in 11G release 1, but the problem is that at the time it was added, SHA-1 was already broken mathematically. So a Japanese guy, I think it was, you can see it on Bruce Schneier's blog, there's a link on the slide, he found there was a mathematical collision between different inputs could produce the same hash. To get around the problem, because with SHA-1 algorithm, they only hash the password. They don't concatenate the username password together again. So Oracle had to generate a mathematical salt, just a number, prepend this to the password, and then SHA-1 that and produce the password hash. So that each password, so if you have 3 users with the same password, it would be different, because every time you hash a password, it generates a new salt. Oracle stores this salt in the S:* field that we saw in the database in a slide a couple of slides ago. That salt has to be sent to the database client every time you want to authenticate to the database. If you sniff the traffic going to the client, the TNS traffic, you find a field called auth_VFR. That is the salt being sent to the client. So it's okay. It's a longer key, obviously, so it's stronger than the DES algorithm. So even though it was broken, I guess Oracle decided to use it anyway, because it's better in terms of key length than DES. SHA-2 was added in 12.102. SHA-2 isn't really just SHA-2, it's PBKDF2. So it does 140,000 rounds of mangling of the input, the password, and the salt again. It then passes that's done in the client, and then it passes that to the database, and the database does the SHA-2. The SHA-2 is pretty fast, but the PBKDF2 is pretty slow. So cracking a SHA-2 password is much, much slower, about 1,000 times slower, or even 10,000 times slower than trying to crack a DES password. So it's better, it's stronger, it's harder to crack, so definitely worth using. The HTTP digest is obviously very weak. This is just MD5, and what it is the it's a concatenation of the schema, the username, XDB, the password, and then the MD5 hash is taken of that. And you can easily just prove this with a very simple PLSQL script. Obviously, it's MD5, and it's a precursor, a predecessor to SHA-1. It's very fast to execute password cracking against this. We must enable the strongest passwords in the database. Obviously, we got possibility in from 12.102 onwards of 4 different password algorithms. So you need to turn off the DES algorithm. You need to turn off the HTTP digest. And from 12.2, there is a different syntax for passwords where you can say HTTPD enable or HTTP disable. So in 12.101 and 12.102, this wasn't possible, but you can now disable that. So if you're on 12.2 and up, you should get rid of HTTP unless you're not using HTTP, unless you're using HTTP digest, and you should get rid of the DES password. You can change the SQLnet version, and this is confusing because the SQLnet version for up to 12 is set to 8. No idea why. And from 12 upwards, it can be set to 12 or 12A. You should set it to the highest number possible. But the problem with this is that you can only do this if the clients connecting to the database are of a high enough version and they actually support the password algorithm. So most sites, this is not possible. So most sites you'll find that users have multiple password algorithms enabled. This slide here just basically shows me setting the version to 8, changing a password. You can see the DES algorithm is there underneath PWD1. I then change it to 12 and the DES algorithm has disappeared. So this just shows you can get rid of the DES password, basically. So we need to talk about password cracking. So we need to know how long it takes to crack a password for the Oracle database. So the goal, as I said at the beginning, is to create a profile to enforce strong passwords for users of the database. So including the length and the key space, the character set, and so on. We can only do that if we've got some idea of how long a password lasts. So if the security section or the business section says we have to change passwords every 180 days, fine, that's okay. But how long does it take to crack the password that you've actually designed? So you need to make sure your design and your enforcement means that the password can't be cracked in that amount of days, and ideally in double that amount of days or more. So to make sure the password can't be stolen and broken easily. So we need to just think about password cracking. There are a number of different types. We could do connection brute forcing, so we can try and connect to the database, pretty slow, maybe 1 or 2 guesses a second if you're lucky. We can check default passwords for the default accounts, easy to do because we can just do that with a SQL statement. We can do dictionary attacks faster than trying to brute force every possible password. And we can obviously brute force every password. So simply start with A and then B and then A, B, and then A, and so on until we've tried every possible password. In terms of dictionaries, you probably always need an English one, but you should have a local language one for the country you're in. So if you're in Slovenia, you'll need a dictionary that's got English passwords and Slovenian passwords. If you're in Switzerland, it's the worst case scenario. So you need French, Italian, German, English, and possibly other languages as well. We can do password cracking pretty easily in the Oracle database. There are a number of possible crackers available. So there are some C-based ones. So OraBF is pretty slow nowadays. It was created probably about 15 or 16 years ago. WROFBF, created by a guy in Hungary called Laszlo Toff, not the guy who smashed the Pieta in the Vatican, but a security guy in Hungary. He multi-threaded his cracker, hence it was faster. So the original OraBF did about 1 million hashes a second on a reasonable laptop. So the laptop I'm on now. WROFBF does about 6 million hashes per second on the laptop I'm on now. There are others such as John the Ripper and so on. There were hardware crackers that people created. So Marcel Mayor, who actually is a colleague of Laszlo, created a CUDA-DB cracker, which you can put on a single graphics card. And this did 200 million hashes a second for SHA-1. And then somebody created IgHash GPU, did 790 million hashes a second. So these are getting faster and faster. But we need to have some understanding of how long a password would last with these tools. It gets even worse because if we look at this article on Ars Technica, there's somebody who created a rig with 25 GPUs in it, so graphics cards, and this did 350 billion hashes a second. I was teaching a training class of mine in Paris about 1.5 years ago, and a guy from a bank in the Far East said, "Oh, we bought this rig, but we bought the latest one, and it only has 6 graphics cards." I'm not sure if it's exactly the same rig because there are a number of these rigs available. He said there's only 6 graphics cards in it, and it does 750 billion hashes a second. So really, really fast. You can build hardware password crackers yourself. There's a guy called Denis Yurachev who did this a number of years ago, created a hardware cracker with an FPGA chip. It wasn't blindingly fast. It did about 85 million hashes a second. I bought this little card here. It's got an English 50 pence piece coin, which is, I don't know, maybe 20 millimeters across. It's pretty small. This is £67, and it's got 4 times the space as the one that Denis Yurachev did. So I put Denis's IPR in this, and I could get roughly a 4 times speed increase because there's about 4 times the space. His code hasn't been tuned, so I can probably get double that. So I can probably get around maybe 600, 700 million hashes a second. So if I parallel this up, you can easily see for £67, I can create myself a pretty fast password cracker. So we need to design passwords. They need to be scientifically designed. You can't just make them up. You can either start with the length of the password and then work out what the lifetime could be and the complexity in the key space, obviously. Or you can start with the lifetime you want to have and then work back to what complexity you need to actually satisfy this. So I created a simple spreadsheet that we can play with. So I've got the worst case scenario here. So 26 characters, just uppercase passwords. I've just said the password cracker is doing 4 million hashes a second. You can see here that, you know, an 8-character password would last 0.3 of a day. That isn't long enough. So clearly 8 characters isn't good enough. If we increase the key space first, so maybe we have uppercase and lowercase digits and maybe 10 special characters. So that gets us to 72, I think, if I've done that right in my head. Then you can see that, you know, an 8-character password will now, let me highlight the line, will now last 1,000 days. So actually 8 is too short, I think, anyway. And also we're relying on the speed of the password cracker being only 4 million hashes a second. So if you just got a graphics card and did 200 million, you know, that drops back out again. So if you look at 8 characters, 20 days. So clearly passwords should not be 8 characters. If you put in the rig that the guy from the bank had, 750 billion, then, you know, 8-character passwords, you can't even tell really how long it takes. A 10-character password's 28 days. And that rig only costs 5,000 euros. So this is, you know, it's not the days of the NSA building hardware and spending billions or millions to create password crackers anymore. The man in the street can do this because of Bitcoin. This all becomes about because of Bitcoin. So, you know, just playing around with this spreadsheet, we can see that the passwords should be long enough and complex enough that they can't be cracked in either scenario. So if we just go back to the slides for a second, so I've nearly finished. The choice of the password can affect, sorry, the password cracker can affect the speed of the choice of cracking as well. So password crackers are written to start with A and then B and C and A, B, A, C. A very simple test here shows that if I have a password of A, sorry, it's 5 A's and 5 Z's, you can see there's a difference of 1 second and 7 seconds. These are pretty fast because they're short. But this means that the password choice, you might think, okay, well, I shouldn't start passwords with A. I maybe shouldn't start them with B. If the CPU has got 2 cores, I shouldn't start them with L. Or if it's 4 cores and so on. We can't go down that route because you quickly basically reduce the key space to such a small space that it doesn't work. So you need completely random passwords. So we need to design profiles. So we need to design the rules for the profiles. And what I would normally do is design 4 different profiles. 1 for the schemas, the accounts that own the data in the database. 1 for Oracle's default accounts. 1 for admin users, so DBAs, support people. And 1 for everybody else. I mean, I've called them power user because these are people connecting directly to the database, not through the application. And you can come up with rules for each of these. So design the complexity, the key space, the length, the lifetime, everything. The key thing is to make sure the default rule, which everybody gets if they're not specified a specific rule, has the strongest setting from all of the others. You also need to design a password verification function. So there's no sort of standard easy way to do this with Oracle. You've actually got to write code and deploy it to the database and then associate it with a profile. You can see an example here that this is still fairly simple to do. You know, we basically saying, you know, we can specify simple rules like must have 12 character length, must include at least 1 letter and so on. We can create various rules, specify the character space, the length. We can specify how different the old password has to be from the new one, and so on. And Oracle provide functions that we can use to do this. So in conclusion, and hopefully I'm roughly on time, we need to understand how the password algorithms in the Oracle database work. We need to get rid of the weak ones that we're not using. We then need to understand at some level how long it actually takes to crack a password, because most people, DBAs, designing profiles or whatever, don't understand this. And then you need to start with either the lifetime of the password and then work out the complexity, or start with the complexity and then work out what the lifetime is, and probably half that, and put it into your profile. We need to make sure the password hashes can't be stolen from the database, because that would mean it's possible to crack them. So we need to lock those down. We need to make sure strong passwords are properly enforced. So we need to design profiles to make sure that every user of the database has got a strong password. And we need to make sure there are no gaps. So quite often when I do a security audit, I'll find that there are profiles for accounts where they've got a lifetime, say, of 90 days, but there's no complexity function. So there's nothing to enforce the strength of the password. And then you find others where there's no lifetime, but there's a complexity function. This is clearly trying to cheat the external auditor to say, oh, look, we've got a lifetime and we've got a complexity function, but actually the two are separated. So you're never going to enforce strong passwords in the database. So that's me finished. If anyone's got any questions, not sure if we've got any time, you can write them into the chat. I'll hang around for a short while to see if anybody asks any questions. So thank you very much, guys.
Thank you, Pete, for an interesting talk.
Thank you.
We welcome our next speaker, Matthias Luft. He's a principal platform security engineer at Salesforce with more than 30 years of experience in IT security. Currently, he works on container and cloud security engineering. So his talk today is Fantastic Secrets and Where to Find Them. Matthias, the floor is yours.
Good morning, everyone. I will just work a moment to take over the presentation. Here we go. So this should work. Can you see the presentation?
It's working fine, yeah?
Perfect.
And we see you. Everything is fine.
Okay, amazing. Good morning, everybody. Yes, I was kind of excited about the title, Fantastic Secrets and Where to Find Them. You've probably seen the movie, and so that was what came to my mind. And I will talk about secret detection today, and we will talk about what that means in a moment. Also, Andrei, thank you for the introduction already, so I won't have to talk much about myself. It's all there. I filled various roles over the last 13 years. At the moment, I work in platform security engineering, which I personally enjoy a lot. And you will see my takeaways from that position or that field of work throughout the talk as well. So what are we going to talk about? We have a modern distributed systems world. At least this is my background. It really depends a little bit on your environment, but a modern large-scale application is not really one application anymore. It's many services. You all have heard of the buzzword microservices and all of that. But even if you look beyond the buzzword and just modern distributed application design, you have lots of different services that need to communicate with each other. And obviously, as we are working in security, when we think about communicating systems, we also immediately think about authentication. So authentication between those different components usually relies on something the application knows. The other ways of proving your identity is a bit more difficult when you're a piece of code and not a human. Code doesn't have biometrics. Code can't really possess anything that it can show off. So secrets in an component-to-component authentication is usually something they know. So a secret in this talk refers to passwords, token, certificates, API keys. In the end, it's all the same. Certificates have a little bit of like a mathematical special position, but passwords, token, API keys, it's all basically a long random string, ideally. So if they get in the wrong hands, your environment is obviously at risk. And we want to talk in this presentation how we can prevent that and how we can prevent that in a proper way without hindering operations and ideally even supporting operations. So going over the agenda, we will talk a little bit about secrets and how they are being used. We will then talk about a secret detection architecture. There's actually already quite some good work out there, but I have some additional hints and information around that to make sure you can actually implement that efficiently. So what type of secrets are we using about? I defined what a secret is, basically a long random string that is used around, and we already talked about that we have lots of components that need to authenticate with each other. So going a little bit into more details, typical connections that you have these days are, for example, connection to a database or a message queue, if you have something more event-driven, or also to a mail server if you need to send out emails from your server. So all those like backend platform services that are using usually require authentication. Then if you have more custom services in your environment, traditional example is that you have like a shopping cart in your shop system, then the shop needs to be authenticated, and to forward somebody, maybe they need to also authenticate to the shopping cart application. One thing that is often overlooked a little bit when we're only looking at like the production deployment of a component is deployment and build services. So for example, when you build code, the build service that you are using often also needs to authenticate with your repository. And if you then have some deployment automation in place, the build or the CI system, however you want to call it, then needs to authenticate to your platform to actually be able to deploy your code and application. So this also goes hand in hand with access to a source code repository for the build services. So all those are use cases why you have secrets in your modern distributed application and why they need it. So the question is, where do we usually find them, those fantastic secrets? So they can be stored in many, many ways. So they can be hard-coded in the application code. I think this is like the most basic old mistake that many of us have already seen in their security career, or probably still will be if you are just getting started. So hard-coded is obviously a very, very bad idea, but then actually the next 4 options all can be a valid option to store a secret. So it can be stored in a dedicated configuration file, it can be stored in a database, or the very modern application development way, it's stored in an environment variable, or we have a secret store. A secret store is usually not much different from a database, except that it has like some more functionality around effective management of secrets. So I think the most prominent solution these days is, for example, HashiCorp Vault, or all the big cloud providers also all have secret stores available these days. So also secrets need to be available to the application at some point. When I train like junior engineers, or when I have an intern that I have on projects with me, they often find secrets in files if it's a more traditional on-premise architecture. And then they get all excited. It's like, oh my God, there's a password in that file. I was like, okay, is that bad? And they were like, yeah, of course, there's a password in a file. You're never supposed to write a password in a file, because what do you learn? You're supposed to store your password in a password manager. So the problem with that is an application needs to access their secrets. There's no human that will enter a password every time an application needs to connect somewhere else. So if the file is dedicated to the secret and the access permissions on that file are proper, and the file is not stored or leaked anywhere where it's not supposed to be, a file for a secret can be a proper solution. There's way better ways to handle things. Absolutely with you on that, but it can be a proper solution if you don't have any other secret management infrastructure in place. So that was a bit longer. And then this is one catch-22 that I wanted to talk about, but there's actually also another one. So if you want to store your secrets, for example, in a database or in a secret store, what's the catch-22 here? And this is where I usually would be happy to take like the input from the audience, but that's in the online versions a bit more difficult. So the catch-22 is obviously to connect to a database or a secret store, you already need a secret. So you at least need one other way to inject a secret into your application to connect to a secret store. So there's a lot around that, and secret management would be a topic for a whole different talk, but we want to talk about secret detection, and I think I already talked for way too long. So we're going to talk about how we can detect secrets that were not stored properly. And in doing so, we luckily can look at, I think, from my perspective, the two reference publications around this topic. So there is one paper, I think it was the first one, that did a large-scale analysis of secrets in GitHub and what they could find there and how long it took for a leaked secret until it was detected and so on. So this is one very good paper to get you started into the idea of secret leaking and secret detection. Based on that, Duo Security actually published a tool and an article on how to monitor GitHub for secrets. So in the remainder of my presentation, I will also focus on version control systems. And personally, I work a lot with GitHub. I have like sufficient GitLab experience, but I work a lot with GitHub. So my presentation will be targeted a little bit towards GitHub, but the principles that I'm talking about, you can apply to many, many other source code management solutions. We're also talking about source code management because this is where I think the majority of secrets are leaked these days. You all have heard about public S3 buckets, and I think that has been like the leakage hype of the last couple of years, but leaked secrets are actually also bad. And I'm not aware of any super horrible impact of a public S3 bucket, but for leaked secrets, there are actually companies that went bankrupt or had to close business because, for example, AWS keys to their production infrastructure leaked. And an attacker deleted everything. They didn't have backups, they didn't have a backup account, and they needed to stop operation of their company because they leaked secrets. So our focus is on source code repositories. Duo Security also created a very nice overview how you want to handle those things. So if you want to detect secrets, you have in your secret detection architecture, you have events. Those events are usually received via webhooks, or you can also poll other systems. We will dive into that in a moment. And those events are forwarded to detectors. Those are your traditional secret scanners that actually get a file or any other data and analyze the data for secrets. If there's a secret detected, you forward that secret to a notifier so that people can work with that. Here's an example for Slack. We also use Slack for that, but it can be a console, it can be an email notification, you can put it into Splunk or whatever, you get the idea. So how do you implement that actually? And now I'm referring a little bit to those webhooks and polling. So I'm not sure how many of you are familiar with Git hooks. Git hooks are basically events that are executed by Git. Git is like the big source code management solution these days, version control solution. And different events then execute scripts. It's really just, in the .git subfolder, you have subfolder hooks, and then you can create those subfolders, and then you can put scripts in there or binary or programs that get then executed. So a very one that we will focus on is a pre-commit hook. So these scripts that are in that hook folder are executed before a git commit actually is carried out. So this is a very good example where you would want on your client system, on your developer system, where you would implement a secret scanner. So this is one example. Particularly interesting hooks could be on the server side. For example, on the Git server side, you have a pre-receive hook. So before any data is actually processed by the Git subsystem, this hook is executed. So if you would want to prevent an engineer from committing secrets into your central Git server, you would execute a secret scanner on a pre-receive hook, for example. I will not go through all of those. Those are for your situational awareness, and you can dig into those. I just want to give you the relevant examples. They are all documented. You can play around with them and handle all of that. So the problem is with those server-side hooks on the public cloud platforms, they don't allow the execution of server-side hooks, which is quite obvious because it would mean they would need to grant you the opportunity to execute code in their central Git server instances, and that is tricky to do. If you operate your own instances of these, like GitHub Enterprise, GitLab Enterprise, you can use server-side hooks. So that is definitely one interesting way to implement those events. And those server-side hooks could basically then just notify your central secret scanner. Secret scanner is scanning the code and then creating those events that you have. What you can do on the client side, I already mentioned that a little bit, you can configure pre-commit hooks. And this is a very interesting thing to handle. So our secret scanner that I will talk about a little bit in a moment is actually also deployed to all of our engineers. And the engineers can then use that secret scanner either per repository. They can even integrate that into their repository template locally on their system. That means any repository that they create will automatically have this secret scanner hook installed. Or you can also run global Git hooks. So any Git action that you execute on your system will also have this global Git hook executed. So this is a very good spot to implement a secret scanner. So a couple of other things that I want to mention. We talked a lot about like source code, version control system, but there are two things that I at least want to mention when we talk about secrets because they are also very important. So one interesting thing is your shell history, especially with AWS and how they handle their secrets. So AWS has a config file where you can keep your access keys, which is not the best idea. So the other option is to export them as environment variables. But if you do that, they show up in your shell history. And that's something that you don't want, because if your system gets compromised, one of the most important files that attackers will look at first is your shell history. And then you have a key in there, and this is something that you would want to prevent. So what you can do for that, for example, is to use the history ignore variable. So if you export this environment variable and you define patterns that your history should ignore, then any command containing such a pattern will not show up in your shell history. It can be a bit annoying. For example, if you perform the command SSH keygen, has the word key in it, will not show up in your history. I was often annoyed by that as well. But it's definitely one way to prevent keys from ending up in your history. Another option that I'm still looking into is the bash logout file or other shell logout, like a ZSH logout. These are scripts that get executed when you log out of the shell. The problem is with our modern window environments, if you just close a window or just close a shell, that does not always trigger a logout environment. So this functionality is not used as often. But something I want to look into, and I also wanted to give you the idea if this is something that might be interesting for your environment. Another super important one is leaking secrets into logs. This is an incident that we sometimes need to dig into, that an application was accidentally logging a password, and that log entry was then forwarded to a central logging system, which must be provided. There is a lot of publication around that, and the idea is usually to establish a logging library that sanitizes log entries, which is basically secret scanning again. So this is also something that you want to keep in mind. But coming back to our secret detection architecture, I talked a little bit on the way to implement that. Duo published a tool that you can use for exactly that detection pipeline. You understand Git hooks a little bit. So you're basically now in a position where it's quite simple for you to deploy such a solution into your GitHub organization. However, there are a couple things that you need to keep in mind when you want to do that. There's a lot of secret scanners out there. You need to choose the right secret scanner for you that covers everything that you want to cover. I think two of the most known ones might be Git Secrets by AWS, but by default, this only scans for AWS secrets. So it doesn't scan for regular passwords or something like that. And then you have Trufflehawk. Trufflehawk has more often like offensive computing focus. So it tries to support pen testers or red teamers in extracting tools. So it's not very friendly to integrate into an automated system. Then we have our own one here, which you think, okay, there's so many. Why did you write your own one? Because it was the only one that did fit our requirements. So this here, Breath, is an open source version of the tool that we use internally for secret scanning. And it scanned everything that we needed to scan. But go through that, make sure like everything is covered. So in GitHub, that for example, it's not only the code that you need to cover, you may want to cover wiki entries, issues, PRs, the description of the repository. It really depends what you want to cover, and then you need to see which tool to use. But this is really only the secret scanner. This is not the secret detection architecture. When you build your secret detection architecture, make sure that you build in support for triaging your findings. Your solution will find a lot of false positives. This is usually just how that works. Detecting randomness is possible, but as we, for example, see here, this commit ID that I blanked out a little bit already looks like a potential password. So it is difficult to make this completely foolproof, and you want to err on the side of caution. So you want to allow for classifying something as false positive. So our solution that we also want to open source at some point basically allows to verify and manage those secrets in Slack. So you have a couple Slack buttons, you click them, and then you can triage them and make sure that you go through everything. Then I definitely recommend support for allow listing and sample secrets. So our secret scanner has a known allow list that basically allows certain secrets or certain paths for excludes files and all of that. In addition, we have across our whole organization a document that contains sample passwords. So if an engineer needs to put a dummy password somewhere, they can use that sample password, and we know, oh, they did that intentionally. This is not a leaked password. We don't need to act on that. So this is also something that is very helpful, especially if you want to build good developer relations. Build your secret detection architecture in the way you would build any product. This is also my opinion on security and how you should operate your security team. So you invest in good developer and engineering relations. Yes, I see our host coming on, so I will quickly jump to the summary slide, but I think it is a very easy summary. I think I gave you illustrations why leaked secrets are bad and that it's an inherently tricky problem to handle. There are a lot of scanning tools out there, but scanning will only get used so far. You want to build a whole process around that. And there's a tool out there that is very good as well, but there's also some stuff that you need to keep in mind to make your detection architecture effective for you. And that's it from my side.
Thank you, Matthias. Any questions from the participants? There is nothing in the chat. You still have some time? No? Okay, so if we receive some questions later on chat, so we will let you know.
Absolutely.
Thank you very much for your contribution.
Feel free to reach out whenever. Happy to chat and enjoy the rest of the conference.
Yeah. Our next speaker is Nikolaos Benias from Hellenic National Defense General Staff, CyberDefence Directorate. He's certified as a web penetration tester, a CCNA, a practitioner, and a GSEC holder. Currently, he's a PhD certificate candidate at National Technical University of Athens, researching on industrial IoT cybersecurity. Nikolaos, the floor is yours.
Good morning. Thank you, Andrei. I hope you can hear me.
Yes, it's working.
Okay. So I'll just need to share my screen now. Okay.
Yes, we see it. It's okay.
Thank you very much. Good morning, ladies and gentlemen. My name is Nikolaos Benias, and I am a cybersecurity expert. I'm also an army officer for the Hellenic Armed Forces, And for the last 10 years, I'm positioned at the CyberDefence Directorate of the Hellenic National Defense General Staff in our MOD. So as a military, this is a much needed disclaimer. The views and opinions expressed in this presentation are those of the author and do not represent official policy or position of any authority. So after this, let's get started. This is the overview of my presentation. There's a small introduction, followed by some scientific approaches to the human factors that are responsible for human exploitation. Next, we are going to see some human emotions analyzed in depth, and some social engineering attacks are presented that I'm sure you are all familiar with. And I will finish my presentation with some conclusions about social engineering attacks. So, social engineering. What is social engineering? In the context of information security, it's the art of psychological manipulation of people into performing actions that they normally not do. Social engineering threats are reported every year to be increasing dramatically in numbers, as we saw also yesterday in some talks. Phishing attacks are the top threat vectors for various kinds of cyber attacks. Let's see who uses social engineering. We have hackers, corporate competitors, cyber criminals, this includes also the organized crime, governments, spies, terrorists, declassified employees, also known as insiders, spammers, pen testers, and others. Their targets focus on, but are not limited to, staff and business executives, R&D departments, finance and marketing staff, customer support, sales, transport, help desks, and basically anyone who has some important information for them. Motives for doing so may be economic, vengeful, intimate, or coercive in the case of blackmail. Let's see how attackers do all that. So, in social engineering attacks, the following techniques can be used. I will just mention some of them briefly in case someone doesn't know some of them. So first we have phishing. It comes from the combination of voice and phishing, and is considered the most prevalent type of social engineering attack. This technique exploits the victim's trust via telephone services. Next, we have shoulder surfing, which is the observational technique to get information while performing some action that involves explicit usage of sensitive and visible information. It can be performed at a close range as well as at long range using binoculars or other vision enhancing devices. Next, we have tailgating, where in this attack, the attacker is seeking entry to a restricted area secured by unattended electronic access control, for example, with an RFID card, and there is no physical guard there to check who is coming in. What the attacker does is simply walk in behind the person who has legitimate access. Why does this happen? Because following common courtesy, the legitimate person who usually holds the door open for the attacker, or the attacker themselves may ask the employee to hold it open for them. For example, they may be carrying something and their hands are occupied, so they kindly ask him or her to hold the door. For several reasons, the legitimate person may fail to ask for identification or may accept an assertion that the attacker has forgotten or lost the appropriate identity token. The next one is a pretty old one. It's the dumpster diving, used since the 80s. So the dumpster diver is willing to get dirty in order to get the information he needs. A huge amount of information can be collected through company dumpsters. I hope nowadays not that much. Usually the information they seek is related to company phone books, organizational charts, memos, policy manuals, calendars of meetings, events, vacations, system manuals, printouts of sensitive data, or login names and passwords. That's the best one. Printout of source code, disks, memo forms, and other stuff. Next, we have pretexting, which is the creation and use of an invented scenario to engage the victim in a manner that increases the chance the victim will divulge information or perform actions that would be unlikely in ordinary circumstances. Next one is phishing. It's, as we all know, the sending of an email that appears to come from a legitimate business requesting verification either of information or a warning of some dire consequence if it's not provided. Later on, I will give you some examples of phishing attacks. Next one, we have baiting, where the attacker is leaving a malware-infected physical device. This is the bait. It could be a USB flash drive most of the times, with a legitimate looking and a curiosity label in a place where it is sure to be found. So the finder picks up the device, loads it onto a computer, and unintentionally he is installing the malware. Next, we have diversion theft, also known as or around the corner game. This is a con exercised by professional thieves, normally against a transport or a courier company. The objective here is to persuade the person who is responsible for a legitimate delivery that the consignment is requested elsewhere, hence the term around the corner. Another one attack is called quid pro quo, which means something for something. This technique promises a benefit in exchange for information, usually in the form of a service, whereas baiting frequently takes the form of a good, as aforementioned. One of the most common types of quid pro quo attacks involve fraudsters who impersonate IT service people and who spam calls as many direct numbers that belong to a company as they can find. These attackers offer IT assistance of their victims. The fraudsters will promise a quick fix in exchange for the employee disabling their antivirus program and for installing malware on their computers that assumes the disguise of a software updates. Next one, we have scareware. This is the tricking the victim into thinking its computer is infected with malware or has inadvertently downloaded illegal content. The attacker then offers a solution that in reality tricks the victim into downloading and installing the attacker's malware. This type of attack takes advantage of pop-up browser windows and advertisements that claim that your computer has been infected. Next one is reverse social engineering, where the attacker convinces the target that he has a problem or might have a certain problem in the future, and the attacker is ready to help him or her solve this problem. In order to succeed, the attacker creates a persona that appears to be in a position of authority so that employees will ask him for information rather than the other way around. If researched, planned, and executed well, reverse social engineering attacks may offer the hacker an even better chance of obtaining valuable data from the employees. However, this requires a great deal of preparation, research, and pre-hacking to pull off. The last one is browser exploitation, which is part of a wider technique called client-side attack, where a user interaction is required, such as clicking a link or opening a document via a browser. So attackers have more statistics, as we shall see later on. Psychologists began to approach man as a whole during the 20th century via different approaches as shown here. All these theories end up to one single common point: emotions. So, in some theories, cognition is an important aspect of emotion. Those who act primarily on the emotions they feel may seem as if they are not thinking, but mental processes are still essential, particularly in the interpretation of events. For example, the realization of our believing that we are in a dangerous situation and the subsequent arousal of our body's nervous system, like a rapid heartbeat and breathing, sweating, muscle tension, is integral to the experience of being afraid. However, other theories claim that emotion is separate and can precede cognition. So, the thing is that emotions are complex. According to some theories, they are often intertwined with mood, temperament, personality, disposition, and motivation. Emotions are a state of feeling that results in physical and psychological changes that influence our behavior. They are also the driving force behind motivation, either positive or negative. Some claim to be syndromes of components, which might include motivation, feeling, behavior, and psychological changes. This is a classification of emotions according to Parrott, as you can see here in the table. In the first column, there is a basic emotion that includes the emotions in the second column, which in turn includes more emotions in the third one. It's pretty detailed, and all these emotions are exploited by attackers. Here we see the basic emotions of love in the first column, joy, and surprise. I'll give you some seconds so that you can check all these emotions. Pretty detailed, as I mentioned. In the next slide, we see another basic emotions, anger and sorrow, with some secondary emotions and more tertiary emotions in the third column. I'll stay here for 5 or 6 seconds more, so you can just check some emotions. Okay, and last but not least, fear. This is the most used emotion of all. Carrying on, let's see some examples of social engineering attacks. So the first one, the victim receives an email stating you have won $1 million or a similar amount, a huge one, and to claim the winning amount, fill in the attached document and forward it to this email. Also, it comes with a warning that we should switch off my antivirus as it may block the download due to highly encrypted digital signature of the document or something similar. So what does the victim do? Out of excitement, as we can see here, out of joy and ardor, he or she switches off the antivirus and proceeds as ordered to download the document and opens it to find it corrupt. Little does he know that a malware was just downloaded and executed on his computer, which allows the email sender to gain remote access. I'm pretty sure you have all received a similar email like this and hope that nobody nowadays does any of these instructions. Carrying on to a second example, many people are apprehensive in the presence of someone perceived as an authority figure. So now we have the emotion of fear followed by a nervousness emotion. It's not the person they are apprehensive about, but most likely the position and power of the person that intimidates them. Attackers take on roles of authority figures such as law enforcement officers or high-ranking company officials to extract sensitive organizational information from the victims. Another example, desire to be helpful. Companies train their people to be helpful, but they rarely train them to be part of the security process. People in their desire to be helpful and to solve other people's queries. So now we have the love and affection emotion, or the sorrow followed by compassion emotion, give out a lot of information that otherwise should not be disclosed to an outsider, as it could give an attacker a chance to get unauthorized access to the target system, causing a possible loss. For example, the attacker might pretend to be a co-worker who has some kind of emergency that requires access to additional network resources. Fear of loss. The victim receives an email stating that, again, you have won a certain amount of dollars, and in order to claim this, you should deposit a small amount in an account number in 10 days from receiving this email. Failing to do so, the winning amount would be declared unclaimed, and there would be a new lucky draw to decide who is the next winner. So out of fear, again, the victim thinks that he might lose such a good opportunity, so performs the deposit to the account number provided. Only after future replies to the email are left unanswered and the next 2 months does not receive this amount, he understands that he has been scammed. Again, this is a very old technique, and hopefully nobody falls for it. Laziness, another important type of social engineering attack. Certain jobs require employees to do only a specific set of activities and do not linger around looking for better ways of doing that activity. This causes boredom to the person who performs the same task repeatedly on a daily basis, and over the time, he learns shortcuts to do the tasks using minimal efforts and still meet the targets. Such individuals over a period of time become lazy and are susceptible to attackers who target such individuals, as they know that they would get the required information with much ease due to the laid-back attitude of these individuals towards their work. Ego. So in this case, the attacker makes the person more emotionally sure of himself and thus removing the logical awareness of the security breach that is occurring. In result, the person being hacked senses no harm in providing whatever it is that the attacker is requesting. The reason that such an attack succeeds is that the attacker is a receptive audience for victims to display how much knowledge they have. And the last one, knowledge about the target system is one of the key factors that differentiate the attacker from other employees of the organization. Many times, due to lack of proper training, the employees are themselves not sure if they have complete knowledge about the product. Social engineers take advantage of such situations by creating a sense of urgency, not allowing the employee much time to think and understand that they are under attack. So, the answer to our initial question should be clear and quite simple by now. Social engineering attacks advantage of predictable human responses to psychological triggers. Reaction is predictable because humans are engineered to respond automatically to certain psychological triggers, almost subconsciously, without giving too much thought to certain things. The only thing we can do in order to protect ourselves is keep training, since primordial instincts must be harnessed and learn to control them. Thank you very much. I am at your disposal for any questions.
So we still have some time left. Any questions from the public? No. Maybe one question from my side. So, yes. What about? Do you have some maybe information in this regard regarding social engineering? Because in the practice, let's say if you have a large company, you can let's say do many trainings, but it's very difficult, let's say, to assure that 100% employees will actually be,
Yes, I understand. This is a process.
One is usually enough for the company. So if
yes, if just one person fails to do so, then the attack is inside the company. The hacker is inside. He gets all the information he needs. This is something that constantly companies should do. They should train their personnel for phishing attacks, especially because nowadays and during this COVID-19 period, there's a lot of emails going around. So they should be able to check, double check, I would say, if the person who sends the email is a legitimate one. And secretaries and stuff that is related with checking emails is very vulnerable into this type of attacks, phishing attacks.
So we got one question from the public. So do you believe that cybersecurity awareness training would be an effective solution, or we need to implement more controls and what these controls might be?
Okay. Yes, for sure, cybersecurity awareness training should be an effective solution, but we shouldn't be solely based on this. Of course, we need to implement more controls, and especially with antivirus checking for attachments in emails and scanning the network for suspicious files all day long should be some techniques that should be already in use in companies.
Thank you, Nikolaos, for your presentation.
Thank you very much.
So unfortunately, I have to inform that due to expected urgency, so the next speaker could not attend, and therefore we will have a 25 minutes break until 10:10. So have a coffee.
Kar se mene tiče, lahko začneš govoriti. Pred nekaj meseci.
Tokrat imamo na preizkusu.
Na preizkus smo dobili. Tokrat smo pri monitorju.
Tole je
tegale jumping sumo robotka, plov novi iPhone 7 in tole napravo. Kosilnica. V seriji člankov o avtomobilih. Šalo na stran. Gre za Google Home. To je
pa neke kvazi gumbe za obračanje strani, ki so eni zadovoljni, eni ne.
Kaj več pa kot vedno. Kaj več pa kot vedno.
Lahko seveda preberete
v monitorju. Kaj več o samem Parrot sumo dronu v reviji Monitor. Kot rečeno, več pa v monitorju.
No ja, evo jih, pa novi e-bralniki.
Ok, Google, good night.
Night night.
Kar se mene tiče, lahko začneš govoriti. Pred nekaj meseci.
Tokrat imamo na preizkusu.
Na preizkus smo dobili, tokrat smo pri monitorju.
Tole je
Tegale jumping sumo robotka, plov novi iPhone 7 in tole napravo. Kosilnica. V seriji člankov o avtomobilih. Šalo na stran. Gre za Google Home. To je
pa neke kvazi gumbe za obračanje strani, ki so eni zadovoljni, eni ne.
Kaj več pa kot vedno.
Lahko seveda preberete
v monitorju. Kaj več o samem Parrot sumo dronu v reviji monitor. Kot rečeno, več pa v monitorju.
No ja, evo jih, pa novi e-bralniki.
Ok, Google, good night.
Night night.
Kar se mene tiče, lahko začneš govoriti. Pred nekaj meseci.
Tokrat imamo na preizkusu.
Na preizkus smo dobili. Tokrat smo pri monitorju.
Tole je
Tegale jumping sumo robotka, plov novi iPhone 7 in tole napravo. Kosilnica. V seriji člankov o avtomobilih. Šalo na stran. Gre za Google Home. To je
neke kvazi gumbe za obračanje strani, ki so eni zadovoljni, eni ne.
Kaj več pa kot vedno
lahko seveda preberete
v monitorju. Kaj več o samem Parrot sumo dronu v reviji monitor. Kot rečeno, več pa v monitorju.
No ja, evo jih, pa novi e-bralniki.
Ok, Google, good night.
Night night.
Kar se mene tiče, lahko začneš govoriti. Pred nekaj meseci.
Tokrat imamo na preizkusu.
Na preizkus smo dobili, tokrat smo pri monitorju.
Tole je
Tegale jumping sumo robotka, plov novi iPhone 7 in tole napravo. Kosilnica. V seriji člankov o avtomobilih. Šalo na stran, gre za Google Home. To je
pa neke kvazi gumbe za obračanje strani, ki so eni zadovoljni, eni ne.
Kaj več pa kot vedno. Kaj več pa kot vedno.
Pa lahko seveda preberete
v monitorju. Kaj več o samem Parrot sumo dronu v reviji monitor. Kot rečeno, več pa v monitorju.
No ja, evo jih, pa novi e-bralniki.
Ok, Google, good night.
Night night.
Good morning, towards afternoon.
Hello, everybody. Welcome back to our sessions. Next speakers are Andrei Cotaie. Did I pronounce it correctly or how it is?
Close enough.
I don't hear you. Yeah. Microphone is not working.
Second.
Can you hear me? Because I was able to hear Andrei.
Can you hear me now?
Yes, something was wrong on my side. Okay, yeah. Did I pronounce it correctly? So Andrei Cotaie or
Cotaie, it's close enough.
Andrei Cotaie from Adobe Security Coordination Center. He's a security engineer specialized in the incident response, and he moved from the public to private sector almost 5 years ago. He spends most of his time involved in monitoring and threat hunting projects. His colleague, Tiberiu Boros, also from Adobe Security Coordination Center. So he's a PhD in computer science, specifically in the field of text-to-speech synthesis. He's currently working for Adobe Systems Romania, and it is associate of a research institute for artificial intelligence of the Romanian Academy. Today they will present a tool named Stringlifier. Please, you can start.
Give me a second. Hopefully you can actually see my screen. Tiberiu, can you confirm?
Yes, it's working fine.
Perfect, thank you very much. So, wait, like this. So, hello everybody, my name is Andrei Cotaie. So today we're actually going to have a short discussion about Stringlifier, but first of all, I want to say I'm really excited to be here, even virtually, and I'm really happy you guys decided to join our session today. So a couple of words about us. I mean, we already had an introduction. So both me and Tiberiu are now part of Adobe Security Intelligence team. The Adobe Security Intelligence team is actually a team under the Security Coordination Center, which was already presented. So the scope of this team is actually to do machine learning / data science oriented research towards for security purposes and to build tools like the one we're actually going to present today. So what's Stringlifier? Well, Stringlifier is actually a tool which purpose is to identify a random sequence of characters in text files. Now, text can actually be anything from a text file to a script to the contents of an APK. It actually can do a little more than identify random strings, but we're going to have a couple of use cases further to highlight this. Now, why did we actually build a Stringlifier? So me and Tiberiu and actually our team work on many projects regarding anomaly detection. Like anomaly detection is the main thing we do, and well, we really like that part of the research. In this case, we are doing an anomaly project in order to detect command lines which might be malicious, anomaly command lines. And we had a lot of command lines from the Unix environment. So on the example we have here, we basically have two command lines which are similar. Let me go back a little. So the idea was we wanted to group all similar command lines together, right? And to extract anomalies, and anomalies are actually the things that actually do not fit in any of the groups. So the two examples we have on the screen, they are extremely similar from a syntax point of view. They're almost identical, but they're really different because both of them have some random sequences of numbers, some unique identifiers inside them, which adds a lot of randomness to them. So from a computer perspective, it's really hard to say like those two commands are really similar, even though from a human perspective, it's really easy for me to say like those are together. So in order to enhance our algorithm and make the computer side easier to detect, we needed to somehow eliminate or replace the randomness inside of the string. So I'm a security engineer, I'm an engineer. I said there is a really simple solution to do this, and I decided to go with regex. Now, I wrote a really small and easy regex there, right? Like basically it's going to look for a sequence of characters between 30 and 100 characters length, which are composed from letters, numbers, and dashes, because that was the example I had before, right? So I applied that really easy for a small function on my string, and guess what? It worked perfectly. Like all the random components were actually replaced with random strings. So it actually needs machine learning when you can do this with regex. Now, a couple of days later, related to that project with a different approach, we're trying to find uncommon file paths. So apparently in the Linux environment, random paths are generated quite often depending on the implementation that's there. So we're trying to apply the same thing, like eliminate the randomness from the paths, group the paths, see what actually doesn't fit any of the groups there. And I took exactly the same regex I had before because it works so smooth, and I applied it this time. Now I have 7 examples here, and as you can see, it worked great on 4 examples. By great on 4 examples, it actually replaced the randomness with a random string. And example number 7, it actually didn't do anything, which is great. That's what I wanted there, right? So for the others, it actually failed because the randomness sequence inside the text was smaller than what I gave the regex. So regex is looking only for 30 to 100 characters, and now it's actually looking for, and those examples are smaller. So what's the engineering solution there? Well, modify the lower limit. So we modified to 20. Now, run it again, and guess what? Now, for example, number 5, where I had a timestamp, it's correctly replaced with random string. It still failed, for example, 4 and example 6, because they're still too small. But the big surprise was example 7. So if we look before, example 7 was untouched, Prometheus config reloader, that was the path. Now example 7, when I went down with the threshold, it's random string. And that's because my regex doesn't really care if the sequence is random or not. It just cares about the length and the content there. So apparently regex couldn't actually resolve all my problems. And this is actually just the beginning. We have IPs, so IPs are important, right? IPs might look random, but they're actually really interesting items in my data set. IDs, I shouldn't start discussing about password and keys. Again, they have a really big significance if I can say like this is a password and not random string. And timestamps the same. Like I think our algorithm actually work much better because we can say something is a timestamp than just say something is a random string. Now, I'm going to let Tiberiu give you all the insights, the juicy parts of Stringlifier and how it's built.
Okay, hi everybody. So Stringlifier is a framework that takes raw text as input and is able to detect sequences of characters that resemble random strings, numbers, IP addresses, unique identifiers, and JVT tokens. The framework is open source, and we also provide a pip installation package for it. If we move to the next slide, we'll see that from the machine learning point of view, Stringlifier is a sequence labeling model that operates at raw character level. It uses character and case embeddings, which are fed into a set of single-dimensional convolutions with a kernel size of 5, followed by a bidirectional long short-term memory network and the softmax output. The softmax output has to be established for every character inside the input sequence if it's part of a character sequence that is a normal string or one of the classes we are trying to identify. I have to mention that Stringlifier uses supervised machine learning. So in order to train it, we actually need a training data set. And of course, I mean, having such a data set is literally impossible because nobody ever bothered to label this type of data before. So we had to build our own data set. And I mean, we had the option to actually build a data set offline and train Stringlifier on it. But instead, and this is probably one of the biggest differences between Stringlifier and other models, we actually decided to write something that would generate the data set, the training data set, during training time dynamically. So to do this, we concatenate various tokens. Some of them are created using an algorithm. So they are supposed to be IPs, random strings, unique identifiers, and so on. Others are taken from a list of 400,000 common English words. We alternate casing, we use special delimiters, we use parentheses, commas, dashes, and so on. And we generate the input data for training. If we move forward to the next slide, we have a couple of examples of the data we generate. So every training example is composed of two sequences. The first one is the input string, and the other one is the mask, which has to be learned by the model. In the mask, we use the special character C to mark normal character sequences. We use H for random strings, U for unique identifiers, I for IP addresses, and J for JVT tokens, which are not included in the example because JVT tokens are really long and it was hard to fit them in a single slide. If we go to the next slide, we have a couple of words on how to use Stringlifier. So this is pretty easy. You can use the precompiled package. In our case, we did a pip package installation with pip install Stringlifier. Then, I mean, in your favorite Python editor, you can just import the Stringlifier from the main API, create a new instance, and apply it on any string you want. Now, what Stringlifier will do is it will take the original string and it will replace the occurrences of special character sequences with their type. If you also set the return tokens to true, which is a special flag in the call method, you'll also get a list of tokens with their original strings, their type, and their start and end offsets from the original string. So you can basically locate them really easy in the original data. So finally, on the next slide, I have a couple of words about the training procedure. So I'm going to start with the data set, and I'm going to start with the disadvantages to end on a more positive note. So this is not real data. It's probably biased by the rules we used in building this data. And you could probably achieve the same results with some deterministic programming. So you can identify IP addresses fairly easy. You can spot unique identifiers really easy. It's probably harder for random strings, as Andrei showed. But I mean, Stringlifier is a machine learning model, so it generalizes pretty well on previously unseen data. The model we built is generic enough to work on most examples. But I mean, the advantage of having a synthetic data set is that actually, if you have any issues with Stringlifier on your own data, you can just modify the rules that are used in composing the training data. You can retrain your model, or you can even, I know, drop an issue on GitHub. And if it's generic enough, such as the case for JVT tokens, which was a request from an external party, we can include it in the training procedure ourselves and retrain the model. So the use cases of Stringlifier, the first one is the one that it was initially built for. So it was made for clustering and anomaly detection. Other use cases include data sanitization in application logs. So you want to remove any keys, passwords that were accidentally logged by your server. And also another interesting use case is detecting accidentally exposed credentials. And in, the next slides, Andrei is going to present how you can use Stringlifier for those types of examples.
Thank you, Tiberiu. So by now, I think it's pretty clear who's actually the brain and who's the muscle in the team. But going further, so we released Stringlifier, and after a couple of days, the marketing department that handles us came back and they were really excited. Like we got a lot of traction regarding Stringlifier, and they just gave us a list of links and so on. So it was cool, except Twitter, Facebook, and whatever we had. At what moment we saw a weird link with I think it was a Russian forum or something like that, and some guys they were saying like how you can use Stringlifier to actually search for exposed AWS keys in APKs. So we said that's actually a pretty cool use case for that. Now let's do a short demo. Demo gods, please be with us. So the first example is regarding CTF challenge I made. So I basically took an entire book, Frankenstein, and I took 2 keys in it and actually hid it. So let me exit the presentation and jump here. Let me run this and I'll get back to it. So I basically have this huge book there. It's like the entire book. I didn't took out anything from it, right? So what I did, as I mentioned, I hid 2 keys in it. Now, regarding the book itself, I did here a bag of words approach, so we have some information. So, well, this for a reason why it didn't show up, but I do have the information here. In the book itself, we had 76,000 words, almost 76,000 words, out of which 7,300 were unique words. So I hid there 2 words. One was a random string, but it was a long one. The other one was short. None of them have numbers and they do not have special characters because I want to be as hard as possible to identify them. So if you do the bag of words and you look at the words and you say like, give me the longest word, you're definitely going to find the longest one or the longest one, but you're not going to identify the shortest one because it's going to blend in. So it's still taking some time. It's usually takes around 1 minute to go through the entire book and to highlight the tokens. Well, it just finished. So those are the random words. So if I take, as I mentioned, this one is shorter, this one is pretty huge, so you can actually look for long words and that's enough. It took 77 seconds, longer than I executed before. Most likely there are some things in the memory. So let's take this one, right? And I'm going in the secret file and I search for it, and here it is. Like I just had the sequence of my monster, my beautiful monster, and this key. It's really hard from a human perspective to get that, and it's even harder from a regex perspective to get that. Basically, you have to match which words are true or not, and Stringlifier does that really good and really fast. Now, the second example, let me go here. The second example is based on what I mentioned before, like leak credentials and harvesting them. So what we did here, we were trying to build a POC. So we went to our internal GitHub, we took one of the repositories regarding one of the projects we were working, and I just added some potential credentials in the project, right? And after that, what I did, I actually executed the Stringlifier on all the files to highlight you like how well it does. The cool part was like we did discover that we actually had one accidentally leaked the API key hard-coded in one of the scripts. So I'm not sure if I should be happy or ashamed of the fact that Stringlifier works. So let me go to this example and let's execute it. So basically I take all the files from this folder, I import Stringlifier, I execute Stringlifier. In this case, I want to see only random word tokens where their length is bigger than 8. I said just to filter some of the things out. So now if you look at it while it's running, I have this finding. It's in the requirements.txt folder, and this is a false positive. It's SDK URL lib3. It looks random enough for Stringlifier, but it's not. Then I have this one, which is definitely a config file. It's definitely a password in the config file. This one again, it's a password in the config files. It's AP1K something like it. It's password looking like also like human written password, right? Now, this one is actually a snippet of the key we accidentally forgot and committed on. I mean, it was our internal GitHub, it was a private repository, but still is there in the history. Right, another password. This again is the false positive. Apparently, our requirements was in multiple files, and again the password. So it does work as intended. Of course, there might be cases here and there where Stringlifier might fail. And that's highly connected to the way we actually train our data. Reporting places where it fails can help us actually improving Stringlifier, making it better. And as Tiberiu mentioned, also like if we have other use cases, we might have the team to actually look at them. Now I'm going to let Tiberiu to wrap up.
Okay, so we have a couple of resources prepared for you. The first one is the link for the GitHub repository for Stringlifier. We have the pip installation package on the downside of the page. And also we have a quick start notebook, which is also referenced by the GitHub repository, where you can actually run Stringlifier without having to install it on your own system. So once again, thanks for attending our presentation. And if you have any issues, just drop them on GitHub. We usually respond really, really fast. And if you have any questions, we are here. Thank you.
Thank you. Do we have any questions from the participants? There are no questions in the chat.
That's okay. We were happy to think.
No, everything is clear. So if we receive any additional question later, so we will forward it to them. Okay.
Okay.
Thank you very much for your contribution, and we can move to the next speaker, Catalin Curelaru from Visma. He is a security generalist specialized into infrastructure and product security areas with strong knowledge of security operations. He works at Visma as a product security engineer, and he's also the OWASP local chapter leader, where he aims to create a strong local security community focused on improving the application security world. Catalin, the floor is yours.
Thank you very much. Let me share my screen. Yeah, I think that should work now.
It's working fine. Thank you.
Perfectly. So I'm Catalin Curelaru, and today I'll talk about how to connect the dots. But first of all, I'm really happy to be here at HEK.SI 2021, and hope that everyone is safe. So the agenda for today, basically, it will be cyber threat intel, what it is, why you should have it, and also a couple of insights how to secure the applications with CTI. First of all, who am I? I'm Catalin Curelaru. I'm working into the product security operations team at Visma, which is quite a big conglomerate company in the Nordic zone, where we have lots of developers and lots of development teams. It's quite challenging also because we are having quite a lot of new acquisitions per year. Last year we've had around 14 new acquisitions. So threat intelligence, it's really important for us to know to not get Trojan horse into our conglomerate. So my areas of expertise basically are CTI, cyber threat intelligence, dynamic application security testing, DAST, and bug bounty and responsible disclosure. And I'm also the chapter leader of Avast Mishora, and I'm trying there to create a local community around application security. So cyber threat intelligence, what it is and why a company should have it. Before digging into this, I want to raise a statement, a principle for the CTI. So if you are not worried, you need to worry. And if you are worried, you don't need to worry. So this is a statement from quite a notorious investment guy in the world. And what actually it means that if you worry about something dangerous, you'll need to take the necessary precautions and, of course, protect yourself. So you don't have to worry. However, if you don't worry about something risky, you will not take those precautions, which, of course, will be more dangerous. So threat intelligence. Threat intelligence, it's knowledge, context, and of course the informed decisions for a couple of stakeholders in your company. When I say knowledge, it's knowledge about the techniques, tactics, or the modus operandi of various threat actors around the world. And all this knowledge in the context of who's that one, what is the motivation, what are the motives, what are the indicators. So everything put into a big context will help to provide a decision for various stakeholders into the company. So you can say that you can know exactly what tools you need to implement depending on what threat actors are after you. So it's both preemptive, but also a reactive solution. So sounds pretty cool, right? So what do you think about the CTI analyst role? Is it something interesting from your point of view, or what do you think is necessary to succeed in this field? Yeah, many of us think that it's a Sherlock Holmes job. Maybe it is, maybe not. But we definitely know that it's sometimes it's a cat and mouse play. But certainly we now live in the digital society where hacking news are constant. And we know that the criminals are always adapting their mode to operate, the modus operandi. So we the good guys, we need to adapt, right? We need to adapt and to know what to do in order to protect better our companies and our society, of course. So in order to do this, we need to be transparent. So I think that transparency among companies, among universities, transparency among all of us, it's really important to know exactly who's after us, what are the motives, what cyber criminals or what nation states are doing what, and we all need to collaborate, all of us. So also conferences like this one, it's really useful because we can share the content, we can share ideas, and we know after that how to protect ourselves. So the threat intelligence lifecycle, how does cyber threat intelligence get produced basically? Raw data is not actually the same thing as intelligence. Cyber threat intelligence is finished product that comes out of a 6-part cycle of data collection, processing, analysis, of course, it's also dissemination and feedback. It's really important. So this process is a cycle because new questions and gaps in knowledge are identified during the course of developing intelligence, leading to new collection requirements being set. So it's a cycle, and an effective intelligence programs is iterative, becoming more refined over time. It's normally in the beginning to not be very spectacular, but in the end it needs to be refined. To maximize the value, basically, of the threat intelligence you produce for your company, it's critical that you identify your use cases. That's one of the key elements, and define your objectives before doing anything else. So a couple of types of threat intelligence, because you can break threat intelligence into a couple of areas, like strategic, tactical, and operational. So as demonstrated by the threat intelligence lifecycle, the final product will look different depending on initial intelligence requirements, sources of information, and intended audience. It can be helpful to break down threat intelligence into a few categories based on these criteria. Of course, we can go further with other categories, types, but will not get into details due to the limited amount of time. But if you're a little Sherlock, then you can find these ideas and these types after the session. So this is just an oversimplification of the types of CTI. In reality, implementation of these types may vary per organization. You can see in this one a broader scope. So with the CTI program, you can go in multiple areas like risk management, into the red team operations, blue team operations. You can also provide context and intelligence to the architecture services. Also, it's really important to get all the indicator of compromise into the detection platforms that you have into your company. This is a broader scope of the threat intelligence. So you can see that it's quite complex. So the best it's basically to learn what use case it's suitable for you. So why you want to have this? Do you connect basically the dots by providing context on indicator of compromise, on IOCs, on the tactics, techniques, and procedures of threat actors? Do you know if someone is mentioning you to some dark web forums, to some dark web marketplaces? Do you know if someone is selling a couple of accounts of your customers or of your company to various locations in not so friendly places? I think that all of this needs to be answered in the context of the CTI platform or a CTI program. And that's providing you basically the context and the context and intelligence to answer all of this. So sounds good. How can we protect the customers? How can we go deeper and protect also the applications? I want to raise with you a couple of insights in the next part. Basically, it will be a couple of key tips and tricks. We think about Visma that we have application security program, and we like to think that it's one of the most advanced security and privacy in Europe. So you can challenge this in the Q&A session. So how we developed the program, basically, we are relying on the OWASP SAM model, the bottom-up approach. And you can see here lots of acronyms. Maybe you're asking, okay, what the heck is with those acronyms? We like acronyms. Yes, we like acronyms, and we like also services and solutions. Because we are a conglomerate, basically, we are a central team of security. We are a central security team into Visma, but we are a conglomerate, and we are trying to deliver to all the companies inside Visma, to deliver services and solutions from the security point of view. So we are offering SSA, which is security self-assessment. We are offering PSA, which is privacy self-assessment. We are offering RA, risk assessment, SPIP, security and privacy incident response, PSOC, product security operations center. We are offering SAST, source code analyze, DAST, the dynamic application security testing, MAVA, manual application vulnerability assessment, ATVS, the third-party vulnerability service. And one of the most powerful, it's SMI. Basically, SMI is Security Maturity Index, which we can have a whole session about it because it's gamification inside the company. So basically, with this, you can provide gamification for all the service delivery teams, and based on this index, the teams will know how mature are or not from the security point of view. And the last but not the least, the CTI solution that we have in Visma and we offer to our company. So you can see that we have lots of services that we try to offer. And one of the most important programs especially for merging and acquisitions, it's the cyber threat intelligence program that we have. And here we have lots of use cases. We started small and we try to build on our use cases. There are two ways here, either to develop your own collection mechanism and to start analyze the data and to validate it and to process it, or to make a partnership with the CTI platform and also rely on a couple of other mechanisms of collection. So it's tricky because either way you choose, it will cost lots of money. So for both options, you need to prepare lots of money. As a general starting point, the organization should develop their CTI strategy based on their business risk levels and, of course, regulatory compliance or business requirements. Because CTI is data that is collected, processed, and analyzed to understand threat actors' motives, targets, and attack behaviors. So threat intelligence will basically enable us to make faster, more informed, data-backed security decisions and change their behaviors for security from reactive to proactive in the fight against threat actors. So I will dig a little bit into the monitoring and operational part, which now it's more mature on our part, where we are concentrating on a couple of things like payment fraud, compromised data, and typo squatting. Also, now we are developing the technical and strategical part, so I'll not dig into this because it will take a longer time. But I concentrate only on the monitoring and operational. So with the payment fraud, basically, we are monitoring sources like criminal communities, pay sites, and other forms for relevant payment card number, bank identifier numbers, or specific reference to financial institutions can provide, because we want to know if we can be affected or not. For this, also compromised data, cyber criminals regularly upload massive caches of username and passwords to pay sites or dark web, or make them available for sale on underground places. And sometimes maybe you need to sneak to those places to get the trust and get that data. So monitoring these sources with threat intelligence to watch out for leaked credentials, corporate data, or proprietary code, it's also a good use case. Also, the typo squatting, it's really important for us because we have lots of domains, lots of applications that are publicly available. So getting a real-time alerts on newly registered phishing or typo squatting domains to prevent the cyber criminals from impersonating your brand and defrauding unsuspecting users, it's also highly important. So with the tactical and strategical, basically we want to outline the tactics, techniques, the TTPs, and procedures of threat actors. So basically, the monitoring part, it's most likely like a surveillance. We are monitoring the tech stack and technology partners to know what are the emerging threats. Yesterday, I think, if I remember correctly, or the day before yesterday, we had a situation like this. A real good scenario with the dependency confusion. Maybe you've heard about it. It's quite a big scope now, and we also try to be very agile with the dependency confusion vulnerability. And late in the night, when the bug bounty researcher posted the research, we found about it, and we tried to find the packet managers that could be affected by this vulnerability. So if you want a couple of tips and tricks in the Q&A about the dependency confusion issue, then just ping me after that, because this kind of issues could be raised and could be flagged with CTI. So main question, do you know what your application contains? Your technology stack basically needs to be correlated within the entire environment. You need to start to connect the dots, basically. If you, for example, know exactly what type of services do you have, do you know you have Angular, you have jQuery, you have what kind of service infrastructure, you know all your public domains, email domains, and so forth, then you can correlate everything to protect against code leaks or other mentions to a couple of nice places where they put the content. So the main thing basically is to have the data that you collect. You need to process it, and after that you need to analyze to understand the threat actors' motifs, targets, and attack behaviors. So how? With queries and alerts against a couple of areas of interest. We are concentrating on a couple of areas like forums, page sites, blog, social media, open web, thread feeds, dark web, code repositories, and so forth. And also the third-party feeds are also in really interesting. So in the last couple of minutes, I want to show you one real snippet, so a real nutshell about how we've managed to connect the dots. So basically, based on a couple of public endpoints and also a couple of internal toys that we have, we've managed to flag exactly what to flag and to receive some type of alerts. In the beginning, it's quite hard because you can get lots of noise, so you need to fine-tune those alerts. But after you know what your software development teams have, then you can play basically with what you have. So you can have CNAME records, Redis cache, Azure, SQL servers, databases, cloud apps, and so forth. So then just watch and listen, and try to put context into that finding. Based on your finding, basically, you will need to see exactly what is that finding. So you can see here we have a false positive. So in that particular case, basically, it was a false positive because we are on the public bug bounty programs, and we are having also private bug bounty program, and a researcher just made a list of domains that were in at the time in HackerOne and now in Integrity. So it was definitely a false positive. We've had also a couple of noise regarding APIs, documentation, and so forth. But of course, we've also get really nice things. So a red flag twice. So a couple of things from the private infra was pasted to a paste bin paste site. So that was a red flag. Was quite interesting because we were necessary to move really fast with this and to take the preventive measures inside the company, because what you put into the paste bin, if you're not the owner or so forth, you cannot delete it. So we are not able to delete the content. We needed to take the measures inside the company. So in a very fast time, we've put all the mitigations actions into our company, and also really nice things that we can see almost daily. Dark web marketplaces mentions. So this one could be from the corporate side, so employees of Visma, or customers of Visma, users that are using our products and are not using the MFA, 2FA, geolocation restrictions and so forth. So we are trying to create also there, based on our findings from the CTI, we are trying to create the awareness and the security trainings to the customers, to just let them know that how useful it's to enable 2FA in order to protect themselves, because a couple of accounts are for sale and they do not know that their account is for sale on dark web marketplaces. So I want to conclude with a couple of key takeaways. Of course, cyber threat intelligence integrates with security solutions you already use, so helping automatically prioritize and filter alerts and other threats. But transparency, I would say, that is the key. Real-time alerts on threats and changes are also highly important. And besides that, it's always learn the TTPs and learn how to protect yourselves. For example, there you can see a learning that we've had around banking web inject, and we tried to learn from those TTPs how can we better protect applications. Just have fun with the CTI, because you can achieve many things. So stay safe, protect your customers, and yeah, wake up. And if you have any questions, yeah, please let me know.
Any questions from the public? We don't have any questions in chat. So if we receive any later, Catalin, we will let you know. Thank you very much for your contribution. So we move on to the next speaker, Božidar Radosavljević, MCT and Certified Ethical Hacker Trainer from MKIT Business Solutions. He will present Microsoft 365 Security Introduction. Božidar, the floor is yours.
Thank you. Do you hear me?
Yes.
Great. Just a second. Okay.
Also, the presentation is working.
Thank you. Just to salute you, everyone who attend today to our conference and my lecture. As we said, my name is Božidar Radosavljević, and I coming from the Novi Sad, Serbia. I'm working in MKIT Business Solution, which is part of MK Group. I'm working on the position of head of infrastructure. My responsibility to lead 4 teams. Technical support, server infrastructure, networking infrastructure, also leading the cloud team who are responsible for Azure infrastructure and Microsoft 365. I'm over the decade MCP and MCT. I also, over the last three years, I participate in EC Council Certified Ethical Hackering and training about that. Also, I'm very active in the Serbian IT Pro community and the lead Vojvodina IT Pro, what we established on the end of the last year. So if you are interested, may support us where we find our colleagues who want to share knowledge about IT Pro technologies. You can find us on the social networking. I will leave my presentation after this on the LinkedIn and our website. Also send the organizers. So if you want any questions about it, I will stay on the chat on the next half hour, or ping me on our social networks or email. Be free to ask me anything. Just little information about our company. And okay, I don't like much PPTs. I prefer demos, so I have a very poor presentation. When I working with Microsoft 365 consultant, I heard often that people coming to me and said, we are using cPanel email servers or bad collaboration tools, old collaboration tools, and we want to switch to Microsoft 365. That is secure. That is Microsoft background. It's okay. Yes and no. It's secure how we made to be secure, how many options we configure. Because of that, I love to showing these options because these options are included in Microsoft 365, almost all included in all license. I said almost, not all. And it's very easy to configure and very rising secure score of your Microsoft 365 platform. So today we will show on the demo how to configure two-factor authentication where we're using Microsoft Authenticator tool. What is company branding and how we use it. Azure Privilege Access Management, Identity Management, how we call it. Some policies, secure score, audit log search, attack simulator, and threat management. It's a short time of this lecture to go deeper in the area of this section because every of that section may be lectured by himself. So I will try to demonstrate all options what we have here to see how they work and how they configure. Okay, that will be a presentation. Now we go here. Okay, I open for this lecture new tenant, free tenant, E5 licensing, and is a trial mode. So this tenant is old by 3 or 5 days. It's not very rich of the logs and the data. So I don't have something I cannot show you, but you will get a point. Okay, please be aware if you open the trial, find where you can open trial without credit card. If you open with credit card, it will automatically take money from your card after the grace period is over, and if you didn't decline your subscription, so be aware. Okay, now I log here like as admin account. As admin account, I'm global admin, so I have this this icon, so I can go to the admin portal. Admin portal is here, and you can see all my users who is created on our portal. Also, all admin centers what we need to manage our Microsoft 365 tenant. I create here some few users to we have something to work. And the first thing what we want to show is how to enable multi-factor authentication. Multi-factor authentication is very useful options because regular users don't like big passwords and have an issue about that. You can enable multi-factor authentications to give him a stronger authentication method on that. How can we do? Click here on the multi-factor authentication. That will open us to new window and give us all user accounts. All user accounts. We select some user accounts and we can disable if they're already enabled or enable. It's very easy. When we click enable, another enable, and from admin side, that is that. It's all done. We can filter here if we want to see a specific user of just user who is have enabled or who is configured. And forced, no, it's enable and configured. Enable is just enable, but is not configured yet. That is all by admin side. From the user side, user must come to the portal and log in with his credential and download from his computer phone or Android or Google or Apple Store his application Microsoft Authenticator. I cannot show you how to work with Microsoft Authenticator because they have policy and forbid sharing the screen. But it's very, very easy. Right. If I remember password. Yes, he will come here and he will set to him he must to configure this. Okay, next. What is beautiful here, he will get a QR code. Next. Next. If he get QR code on the application, he will just turn on application start camera and scan this QR code. After a few minutes, all setup will be done. It's nothing more. It's very, very easy. Every average user who once at a time download any application from the Google or Apple Store can do this. It's very easy. We also here have some settings. What we can change is how will behave our authenticator app, how much time is grace after he authenticate over application. It's good to be about less data of 19 days, 30 days, 15 days is the best for that options. That it will be all about multi-factor authentication. It's very, very easy. When we're looking at these users of identities on the Microsoft 365, they're all stored in the Azure Active Directory. Azure Active Directory is a part of every Microsoft 365 tenant. And he have a name Azure, but he is in Microsoft 365. He coming in the multiple flavors, licensing models. Standard and premium, it's mostly name what we're using when we're talking about Azure Active Directory. So these options, what I will show you in Azure Active Directory is 80% are included in free. I will mention what is in premium options. I have free standard edition. I don't have a premium, so you will catch it. Okay. First, what I want to show you is policies, where we can set up different policies, how we want to authentication behave on our 365 tenant. If you have a premium, this will be much more and much granular. Also, we can create password policy, how much time is lockout threshold, how much the password he can miss. After that will be locked on some duration. Also, very cool feature is where we can put some passwords. Sorry. What we want to show on our password list on our users. So the user cannot set our name of the company or the school passwords from different vendors or something like that. That is very, very useful option. Also, it's very, very useful is a company branding option. Company branding option is very, very quick win for sales, for management, for IT, for everyone. Why is that cool? Because we can configure and put here a company background, a company logo, and a company banner. we have here predefined what is the image size, file size, and file types. When we put all that here, we will get all company branded. I can show you, sorry. Check how that work in my company. Different account. I came to the Office 365 portal, and that is cool. When I put my MK solutions, I will already get my branding to see that I am on the MK group. Also, some other company will be get same as well. So we can instruct our users. So if you put our credentials and you see our company branding, okay, cool, proceed. If you don't see, stop. That is not our Office 365. Marketing love it because look it nice. Manager love it, look it nice. But IT have bigger picture. Why is that cool? Also, we have here on the security stack custom access that is part of premium, where we can set up policies on based on the location and device for our users and how will be authenticate or access to our resources. For example, if he is on the secure location like our company network, I don't ask him to use the dual factor authentication, but if he outside, he must. If he is an inside company, I will give him access from the company laptop and company location, access to super cool secure application. But if he is outside of company and using private computer, I will not. He will have denied access to the company some resources. Maybe other will be have, but for some specific will not have. Also, we have enterprise applications here. That is very, very cool feature because we can integrate third-party applications with Azure Active Directory and use the same identity for authenticate, for example, on SAP Cloud and Office 365 in the same users. So our users have one identity to authenticate on the SAP Cloud and Microsoft 365. There is a bunch of application what we can use, and also our application, custom-made application, we also can connect with Azure Active Directory. One more application what I want to show is Azure Privilege Identity Management. It's very cool feature. It's part of Azure Premium. It can more secure our global admin, help desk admin, and admin accounts, especially for company who outsource IT staff. Because of with this tool, I must request for access with admin privilege, and you approve me request on the 1 hour, 8 hour, 1 day, how much time I need. Also, you can review all requests, describe why you did not give approve or why you did granted access or something like that. And also for the some history data, you can export this information and save it for other privileges. So this is what we can get from the Azure Active Directory on the fast track for now. Also, what we can show, just to fight with this toolbar, is security stack. Here we have security admin center and compliance admin center, and we can use it on also. Please be aware what license you buy. Did you buy enterprise mobility and security or didn't with your Office 365? Because of this, some options may be missing from here. How you know Office 365 and every cloud platform is rapidly developing and constantly changing the name and also. So it's not a rare situation to find something like this. You go here, you know that option is here. You get some yellow flag. Okay, it's not red. I don't care. Search. Nothing happened. What is problem? Problem is that option is switched to compliance now. And if you switch on the compliance, that options work perfectly. Second to open. You can use to filter all kind activities, all kind of users or something like that. Because it's new system, I can say give me all, it's be okay. You can see a lot information when some user is logged in from there, when is a user created, modified group or something like that. So much information about our Microsoft 365 tenant you can get from these tools. Also, you can pull this information via PowerShell, so you can export to some Excel, CSV file or something like that, and integrate in your some tool or analysis for later. But I want to say to check these options, it will be okay. Okay, we have protection.com. Also, we have security.microsoft.com. That is two portals where all security will happen. What we want to show now is Secure Score. Secure Score is the free tool. Is very nice tool. Now it's still not working because it's new system. But we'll get some number. What is our score of security based on security measurement? What we configure on our system. And we will get maximum number what we can get. Also, we will get recommendation what we need to configure to rise that score. Be aware that some of configuration may require some higher licensing that you get. So read carefully before you start to implement some configurations. Also, we can see a history on the timeline, how we implement which measure and how our score, I hope so, rising to the maximum score. Also, you can see here and comparisons with similar tenants like yours, and of number of users, services, what you use, what is average score, and where are you? So we're trying to beat so much as possible that average and try to go to the higher. But it's the beautiful tool, and for someone who first time configure security on Microsoft 365 is the good starting point from where he starts to implement. Okay. Also, what we have here is threat management. What we have here is something what we're calling attack simulator. Attack simulator is retired from this screen. It's now switched also on the secure, but here is the better picture so I can show you. We have some attack simulations, what we can send for our clients. So we can see how it's security awareness of our users and see what measures we must take to get awareness on the higher level, trainings or what we needed. We can use some of these tools to start something, and I already start some phishing campaign where my users get email like this, where is some Word document file where he can find some Word document, also link also, where when he click on that link, he will get I will get a report about my here is my I will get report who of users are enter credentials, who of users click on email or something like that, and I can take actions about these situations. Also, we have policies, which is very nice, and we need to configure that policies about anti-phishing campaigns, so we can define policies to block some suspicious links where is a capital A and pipe sign substitute or something like that. Also, very nice tools, safe attachments, safe links, where Office 365 check your links, and if we find some, we try to detonate in Microsoft safe environment. If we find that attachment is suspicious or malicious, we delete that attachment, and user get just a notification that attachment is infected, and that is be done. If it's false positive, he get his attachment on his email or SharePoint or wherever they want to get. Also, safe links, working on the same principle like attachments. If we send him a spam message in the link, he will check that link before he gets. Configuration analyzer, also like a security score, is a very nice tool where we can find some recommendations also of what we can configure to our system working better, and our users will be protected on the machine. So if also we have here something for adoptions, just to say, do you want to configure and adapt or modify, we can configure that. That is very also very cool feature. We nearly on the end. That will be a little bit all of the demo. I just want to show you a quick Microsoft switch from the very hated TechNet to the docs.microsoft.com. It's better solution than TechNet. It's very up to date. So I leave in the presentation some links about portal, because many users don't have idea to exist some portals like security.microsoft, protection.office, portal.atp.azure.com, and I like to always to put links, and I very often use that site to find link what I need to not remember that. I also include it in my PPT, so it will be included. Also, what is included in Microsoft Compliance and Security Center, also divided to the the licensing what you have, so you can see what licensing client have and if some security feature is enabled or it's not. Also, complete security documentation is very nice, so you can find it here. And Microsoft Learn is new site where you have security engineer role, where you can find a lot of videos and articles. Also, if you have Live ID, you can log in and get some kind of free certificates and very nice materials like learning snacks for security, Microsoft and Azure stack. This is all based on cloud, Microsoft 365 and Azure mostly. It's very rare about on-premise technologies. Okay, that will be all about the demo. I return to my presentation to
could you wrap up? So because
yes, I'm done. All just to see your references here. Summary. Just to be aware, this options is not default setup. You must set up for every user. Every user must set up manually multi-factor authentication. If we don't set up, they don't have included there. For now, is no policy for automatically included, something like that. Must be attention for the small companies who don't have ITs, and because they often have his security breaches and misconfigurations, something like that. So if you have any questions, please be free to ask. Andrei, please tell me if someone have some question. Also, I'll be here next 30 minutes, so everyone who needs chat, just mention me and I will reply. Also, I said leave my contacts on the PPT, so you can. Thank you for listening, and that will be all from my side.
Thank you too. So currently there are no questions in chat. Any questions for participants? No? No. So if we receive some questions later, so we will forward them to you.
Thank you very much. Thank you for your attention.
Bye-bye.
Thank you very much. Bye.
So our next speaker is Thomas Weber from SEC Consult, an Atos company. He is a security researcher and consultant with a focus of embedded device security reverse engineering. So he has quite a lot of experience in IoT, embedded industrial environment. His talk today is Army of Undead Tailored Firmware Emulation. Thomas, the floor is yours.
Hello, can you see me? Yeah.
Yes.
Okay, nice.
Can you share the screen?
Yeah, of course.
The video has disappeared, so now we don't see you anymore.
Yeah, okay, give me a second. And okay, now?
Okay, now it's fine. Yeah.
Okay.
Everything is working.
Okay, thank you. So yeah, let's start. My talk today is about firmware emulation. Some of you may know some frameworks for that, but I have started a whole project few years ago, and yeah, it was researched at University of Technology in Vienna, and I did some case studies and published some advisories with the company SEC Consult. So the company, just a short overview, is based in Vienna, in KL, in Singapore, in US, and so on. So we are basically worldwide, and now we were acquired by Atos. About me, I'm with the company since 2015, and yeah, I'm just a security consultant, but I focus on IoT industrial devices, and mainly on embedded security and hardware security, of course. So what will be my talk about? Just why did I do firmware emulation? Why did I do the whole project? What's the whole process nowadays? So of firmware development, and how can you detect architectures, essential parts like firmware file systems, and the whole structure of the firmware, and so on. How can you prepare fake images after you have detected the architecture and the whole components within the firmware? And then I have prepared some demos, demo where you can see how emulated firmware behaves, and then a few other things like monitoring and debugging the outcome of the whole study, some vulnerabilities that we've identified, and yeah, a conclusion and what you can do in further steps. So the whole study was based on Linux-based firmware with a binary interface, so no complete real-time OS like VxWorks or Windows maybe can cover it in the future with a similar approach, but was not implemented for this prototype. And of course, dynamic analysis. So it runs, it gets executed on a virtual machine, which means that you can start attacks on libraries, on networked services, and you can also execute known exploits. So that means you can actually try out exploits that you can find on the internet. And it was also done in the frame of a feasibility study. So whether it is really possible to do that with open source tools and on a larger scale. So it's not a ready-to-use tool. It's nothing that is just one script and that you can just start. But yeah, it was just a study. And we've covered 200 firmware images, which may not sound really much, but we have also covered 50 vendors. So just picked 1 or 2 firmwares from each vendor, sometimes 4 or 5, because the firmware base was really different. But yeah, so it was a large scale, but with just few particular samples. And we have also released advisories just based on emulated devices only, so without any hardware. The whole project was started in January 2017, sorry. Yeah, why did we do that? So you can do it in times of coronavirus, for example, by just doing remote testing without having the hardware, just with frame conditions. You cannot test everything, of course. It was also helpful for a lot of customer projects and for research projects. And dynamic analysis is currently limited to few architectures like ARM and MIPS, but not Super H4, Spark, and other stuff. And static analysis is well covered by a lot of tools. There are commercial and non-commercial tools. I have put some pictures of different tools here. So the nowadays firmware development works like nobody wants to do work twice. And build root is a very handy tool where you can just compile a lot of firmware. And most of projects regarding such embedded devices are just based on development kits. And yeah, that can be really painful because a lot of development kits have known vulnerabilities, but they get reused every day. And yeah, end of life, time to market, and outsources are really prominent words. And you can see that, for example, on one vendor contact timeline that we produced within advisory release. and the vendor just stated, yeah, we have to wait because yeah, it's very difficult to get an update from the OEM. So the vendor has not even written the firmware by himself, just getting third-party firmware, third-party hardware, and so on. And for the development kits, it's the same. So a very prominent case that we've published a few years ago was Xiongmai, and more than, I think, 100 vendors were using the same development kit. So who is developing firmware in-house? Yeah, that's the question. And storage of firmware is often done via commercial off-the-shelf parts like SPI flashes, like NAND flashes, and distribution of firmware is often done via self-service. So you can just download it from the website. You can just upload it to your IP camera, to your router, whatever. And sometimes you can also use FTP servers for downloading, or you can request the firmware, which is the case for some industrial vendors, so that you get the firmware via email or a link via email. And yeah, the upload works via web interface, USB sticks, sometimes SD cards or TFTP, and in rare cases via JTAG, but that's not often the case. How can you extract firmware from devices, from real devices, from hardware? You can extract it via JTAG, ISP, or other programmers. And for some, it may be locked. You can also use chip-off techniques. We have also a project here for that. And you can also try to sniff it via the bus, for example, via SPI. And other possibilities are side channel attacks or scanning electron microscopes. But yeah, that's just the case when you really want to get out the firmware from the device and you have no other possibility to do that. So all beginnings are difficult. When you want to build a firmware emulation system, then you can choose present solutions, or you just build your own, like I did, with change root in the target, modified kernel, and I combined build root and QEMU. And when you prepare that, you have to build an environment which can be used to emulate the whole firmware. But for that, you need to detect the real instruction set. You need to detect which library was used or which libraries were used. So sometimes there are multiple. And you have also prepare startup scripts by scanning RCS, init tab, RCD, or initd. So you have to build a suitable environment for each firmware. And how can you detect the root file system? Some vendors are offering proprietary solution to do that, but it's really easy because you just have to pick the root file system, or the obvious root file system, which is the biggest one. And yeah, the only constraint is that the file system must be a Linux-based file system. So yeah, you have also to implement plausibility checks, like are there even executables in, or are there libraries in, or is it some different system, not BusyBox, but for example, just system 5 with bash or with sh without the BusyBox binary, because BusyBox is very often used in firmwares. And yeah, to detect the root file system, you just pick, as I told you before, the biggest one. So if you have squashfs and inside some Linux looking like based file system with MNT, etc, USR, whatever, all these directories that you can spot in a typical Linux-based file system, then you just have to pick the biggest one. And if you do so, then usually it's the right one, and usually it's the root file system. And the other one often can be merged into this file system. For identifying the architecture, you can use version magic strings. You can also use some pointers from readelf or from file, but it should be a combination of all of those so that you can really be sure to have the right architecture detected, because otherwise it would not work. So yeah, the instruction set also matters, because if it's MIPS 32R5 or if it's MIPS 32R2, it's a difference. And also for ARM hard float and ARM soft float. So libraries are also relevant when you want to cross-compile binaries for your target system. Then you have to use the right library. So it must be the exact fitting library where it cross-compile. When you use shared libraries for your binaries, for example, for trying exploits on glibc, then it's really crucial to use the right library, because otherwise it wouldn't work, of course. And for the script preparation, where you have to prepare startup scripts, it's also really crucial to look into init tab first, if it's possible or not, because sometimes init tab is missing in the extracted file system. And if not, you can just search in etc init, etc rcd, and yeah, just list all those startup scripts and hope that it works. Sometimes it works, sometimes not. So we used those 200 firmware samples across those 50 vendors. You can see some of the static analysis I did. So how many glibc libraries, so glibc, libc, hard float, soft float, muscle, and whatever was used. So most of the time it was libc and the microcontroller library. So both of them were spread over the most of the firmware images. Some other images were using other firmware images, were using other libraries, but most of them were concentrated on those two. And you can also see that ARM is, yeah, very often used as well as MIPS. But for MIPS, it was most of the time MIPS big and little endian. For ARM, it was just little endian. And there are also some other exotic architectures which are used sometimes. So yeah, we have to do the pre-analysis, how the image is built, is constructed. That is done. We have to build a suitable environment that you can do with build root. And for the security analysis, you can exploits. You can also use those templates from QEMU to do so. And yeah, to identify the file system and create the firmware image, that's a straightforward task, as well as starting the image by using change root and switch into the target firmware. And running all the startup scripts, I've also explained that before, is also straightforward, but it does not work in all cases. So yeah, you have to have fun while running partial, because sometimes some services are not started correctly. And architectures which were covered during this project were ARM32, hard float, soft float, little endian, big endian, and some other MIPS processor architectures, and also PowerPC, Super H4, and yeah, some Intel processors. And as network, a bridge network into my private network was used, or in the corporate network. And yeah, then I just started it via using QEMU, and it may be also possible to load kernel modules, the dynamic kernel modules, but that's not always possible because of the kernel versions. And yeah, when you want to run kernel modules, then you have to use the right kernel version in build root, which you can pick, and then it will work, or it may work. It depends whether hardware is used or not directly via a static kernel module, for example. And yeah, just look into some emulated devices. I have started some, namely a control device, which has this IP address and which is a MIPS device. Then another device from Advantech, that's also an industrial vendor, which is using an ARM processor, instruction set 7, and Phoenix Contact device, also another IP address, and that's a bit older ARM processor, but that also works. And you can see it's emulated because welcome to product name not found, industrial managed switch. So yeah, that's the case when you try to run firmware, and it's a bit slow. You can see it behaves like, yeah, I want to run faster, but it's not a real processor, it's an emulated device, of course. So it behaves a bit, yeah, laggy. And there's the other device which has this IP address. Oh, it's done now. And there I can also click around, and it's also a bit slow and laggy, but that's how it is on emulated devices. And when you are using your private notebook for that, which is not really powerful. And there is another one, the Phoenix Contact device, where you can log in and hope that it works a bit faster. But yeah, all of them are a bit laggy, and yeah, it is how it is. And those devices were directly pen tested, and some of the implementations were really bad. But yeah, also in 2020. But yeah, it was possible to identify command injections and other vulnerabilities. But I think time is running out, and I cannot show you much of that.
You have anyway, 5 minutes left, so some time left.
I have a bit more, and yeah. And for monitoring and debugging on the virtual machines, you can of course use commands, Linux commands like ps, topnetstat, and tcpdump, which is often very useful, and which was also very useful in a project last week, where colleagues and I tried to do a security assessment, a deep security assessment of yeah, CPE device, and we cross-compiled those tools because most of them were not on the target device, and yeah, used an USB drive, copied it to the temporary file system, and executed it there. And it was a little bit painful because you had to cover the right vector floating point instruction set, and yeah, a lot of things. And the re-cross compiling was also a little bit painful because yeah, it consumed 30 minutes or maybe sometimes a bit more. Yeah, that's a bit bad. But anyhow, when you have set up such emulation system, or at least build root with the right architectures, so that you can leverage from that, it's really helpful for doing firmware security assessments or security assessments of embedded devices. And for emulation, of course, you can also do it completely remote when it works. And also static builds of S-trees, L-trees, and wall grinds are also really useful, also from GDB, so that you can debug processes which are running on the actual system. And one thing which is extremely useful, if you have it, is perf. So a kernel tracer where you can see which commands are executed, and where you can pull out how often exec and whatever was called. So that's really good. That's really fine. and for doing analysis of emulated or on live system, on a live system, yeah, it's really helpful. But you cannot patch a live system because otherwise you would have to replace the kernel, and yeah, that's not often really possible. The samples were taken from those vendors, so a lot of vendors, maybe you know some of them, and yeah, the whole outcome was that 89% of the whole firmware were emulatable, which means you can start the HAL, so SH, ASH, or BASH, or BusyBrox, which contains all of those commands. And 18% inferred TCP listeners, and just 8% inferred UDP listeners. Some of them were network management systems called NMS. And known vulnerabilities that were automatically tested were those, so unzip, glibc, get address info, ghost buffer overflow, and shell shock. And most of them which were found in those samples were unzip and the ghost buffer overflow, just by using present exploits and just cross-compiling them. And yeah, other vulnerabilities where I've put links in here that you can look up later, were also published, and unpublished vulnerabilities which are currently pending and are sooner or later published, are also in the pipeline. So one of the last slides is just the example of the Phoenix contact, where you can see in the web server binary, in the CGI binary, not in the web server binary, that there is a run shell command used directly on the file name of the configuration file, where you can just put in / and semicolon, and then just a command and execute it on the device, which is really funny. And yeah, you can try it out by yourself, but there's also proof of concept in the advisory, which is in the link in the previous slide. So the conclusion is, if you want to build a really cool firmware emulation system, you can just use QEMU and Buildroot. And other things which I tested a few years ago was using pre-built Debian images, but that's not really funny, and please stay on Buildroot, that's better. And also building kernel from scratch without Buildroot, that's also not really funny. So Buildroot is a really cool build system, so just use it. And yeah, just using the target firmware file system only is also not a good idea, because then you don't have all those analysis tools. And with Buildroot, you can just recompile it and use changeroot. There are other improvements, but I think we are running out of time, and then I don't want to cut your lunch break. So thank you, that's it. And if you have questions, just reach out to me.
So currently there are no questions in chat, but if we get it, we will let you know. So thank you, Thomas, for your contribution. Now we have lunch break, half an hour. So we continue with our sessions at 12:20. So see you later.
Kar se mene tiče, lahko začneš govoriti. Pred nekaj meseci,
Tokrat imamo na preizkusu.
na preizkus smo dobili, tokrat smo pri monitorju,
Tole je
tegale jumping sumo robotka, plov novi iPhone 7 in tole napravo. Kosilnica. V seriji člankov o avtomobilih. Šalo na stran, gre za Google Home. To je
pa neke kvazi gumbe za obračanje strani, ki so eni zadovoljni, eni ne.
Kaj več pa kot vedno,
lahko seveda preberete
v monitorju. Kaj več o samem Parrot sumo dronu v reviji monitor. Kot rečeno, več pa v monitorju.
No ja, evo jih, pa novi e-bralniki.
Ok, Google, good night.
Night night.
Kar se mene tiče, lahko začneš govoriti. Pred nekaj meseci,
Tokrat imamo na preizkusu,
na preizkus smo dobili, tokrat smo pri monitorju,
tole je
tegale jumping sumo robotka, plov novi iPhone 7 in tole napravo. Kosilnica. V seriji člankov o avtomobilih. Šalo na stran, gre za Google Home, to je
pa neke kvazi gumbe za obračanje strani, ki so eni zadovoljni, eni ne.
Kaj več pa kot vedno,
lahko seveda preberete
v monitorju. Kaj več o samem Parrot sumo dronu v reviji monitor. Kot rečeno, več pa v monitorju.
No ja, evo jih, pa novi e-bralniki.
Ok, Google, good night.
Night night.
Kar se mene tiče, lahko začneš govoriti. Pred nekaj meseci,
Tokrat imamo na preizkusu,
na preizkus smo dobili, tokrat smo pri monitorju,
tole je
tegale jumping sumo robotka, plov novi iPhone 7 in tole napravo. Kosilnica. V seriji člankov o avtomobilih. Šalo na stran, gre za Google Home, to je
pa neke kvazi gumbe za obračanje strani, ki so eni zadovoljni, eni ne.
Kaj več pa kot vedno,
Pa lahko seveda preberete
v monitorju. Kaj več o samem Parrot sumo dronu v reviji monitor. Kot rečeno, več pa v monitorju.
No ja, evo jih, pa novi e-bralniki.
Ok, Google, good night.
Night night.
Kar se mene tiče, lahko začneš govoriti. Pred nekaj meseci,
Tokrat imamo na preizkusu,
na preizkus smo dobili, tokrat smo pri monitorju
tole je
tegale jumping sumo robotka, plov novi iPhone 7 in tole napravo. Kosilnica. V seriji člankov o avtomobilih. Šalo na stran, gre za Google Home. To je
pa neke kvazi gumbe za obračanje strani, ki so eni zadovoljni, eni ne.
Kaj več pa kot vedno,
lahko seveda preberete
v monitorju. Kaj več o samem Parrot sumo dronu v reviji monitor. Kot rečeno, več pa v monitorju.
No ja, evo jih, pa novi e-bralniki.
Ok, Google, good night.
Night night.
Hello, everybody. Welcome back to the afternoon session of HEK.SI conference. So our next speakers are Julian Suleder from ERNW Research and Dina Truxius from Federal Office for Information Security. So Julian is a security researcher and penetration tester at ERNW Research. His special research interest is in the security of medical devices, as he holds a master's degree in medical informatics from Heidelberg University and Helibron University. Dina Truxius, Dr. Dina Truxius joined the Federal Office for Information Security in Bonn in 2018. Her major tasks cover medical devices, IT security, project management, standardization, national and international cooperation, committee work, as well as disclosure processes. So please, the floor is yours. So today's talk is medical device security results from project ManiMed.
Yeah, thank you very much, Andrei, for this very kind introduction. I think it's nearly superfluous to introduce ourselves or our talk, but I would like to present first of all me. So I am Dina Truxius, as nicely introduced. I'm working for the Federal Office for Information Security, and I am the project lead for Project ManiMed, which stands for Manipulation of Medical Devices.
Also, hello from my side. I'm Julian Suleder. I was the researcher or the project lead from the technical perspective in Project ManiMed, who led basically the people that assess the different products.
Yeah, so let's start with a quick overview of our talk. So the main topic is medical device cybersecurity and the project ManiMed, which stands for Manipulation of Medical Devices. We will briefly go into the product categories that we assessed and about the contents that we recently published in our report. We will also show you some experiences, especially in terms of the complexity of communication systems and vulnerability management processes that we performed throughout the project, and for sure the technical analysis about assessing those product systems. And we will finally end with some conclusions, further information, and an outlook. So what is exactly Project ManiMed and why did I initiate it? So as nicely introduced, when I started in 2018 at the Federal Office for Information Security, BSI in German, there were lots of press articles and concerns in society about the IT security of medical devices, especially in the field of implants. There was a big concern, which might be a result of a series such as Homeland and also maybe Dick Cheney's worries about getting his pacemaker hacked. So I asked myself, how realistic is such a scenario actually? Has anyone successfully hacked a medical device? And what is the impact on patients if such devices get compromised? And to answer these questions, I started Project ManiMed in 2019. So within the project, we could for sure not access all products on the German market in the field of medical devices. So we performed a market analysis to select for newer medical devices and highly connected medical devices. So meaning as many interfaces as possible to have an appropriate attack surface. So the selected products out of 5 categories were then subjected to deep security assessments. So maybe you ask yourself which network devices we actually selected. We selected 2 devices out of the 5 following categories, namely implantable pacemakers or defibrillators, including programmers and some other equipment. We assessed insulin pumps, ventilators or anesthesia devices, infusion and syringe pumps, and also patient monitors. Due to the COVID or still ongoing COVID-19 pandemic, we only assessed one ventilator. We initially had in mind that we assess 2 products out of each category, meaning 10 products in total. But as I said, we assessed only one ventilator because we already had it before the outbreak. And instead, we analyzed actually 3 infusion and syringe pump systems and a pump management software additionally. So we managed to assess 10 devices in total. So what are actually the contents of our report? We recently, basically end of last year, on the 31st of December in 2020, we successfully published our results in German and English. And what is actually the content of our report? Why maybe does it make sense for you to read it after our talk? So first of all, I think it's important to mention that medical devices cannot be purchased or hacked by everyone. So in the project, it was really most important to get in contact with the respective manufacturers and to work on a trustful and transparent basis for an active collaboration and cooperation, basically throughout the whole project, before and after. Because of this trustful basis, we were able to get such products and the infrastructure components, and we were able to find most of the vulnerabilities because we had such a big and good environment that was reflecting really somehow the truth. So we had systems that are comparable to those used in hospitals, for example. Having all stakeholders, namely manufacturers, security researchers like Julian, and authorities like me on a table made this possible. So my project aims to increase the awareness for IT security in medical devices and to establish and maintain a transparent communication. Nowadays, or still nowadays, medical device manufacturers rarely talk about vulnerabilities in devices because that even causes panic among the society when we think about those press articles that gave an influence to this project initially. In my opinion, we should talk about vulnerabilities instead of insisting to have secure devices at all time, which is in the field of IT security not really realistic, right? So no matter if you have a medical device or a smart refrigerator, this applies to every system where IT is in. Further, my project aims for a feeling for vulnerabilities to allow manufacturers and users to identify really the assets and to address also questions that everyone is facing in the field of medtech. The report, as I just said, is not only about hacking devices. It also covers subsequent processes like coordinated vulnerability disclosures, and we also illustrate our lessons learned and our experience. So why did we find vulnerabilities in medical devices? How can that be? Those things are highly regulated. So maybe here are some points that can answer this question briefly, or these questions briefly. So each medical device and its infrastructure is unique. Some devices communicate, for example, via Bluetooth. Some are connected via a network. It is assumed that there is a trust relationship between the components, which is not necessarily the case in the truth. Vulnerabilities can exist, as I said, in every IT system at any time. It is therefore not unlikely that a compromised entity is trusted and participating in the communication. We observed chaining vulnerabilities more often rather than single or individual vulnerabilities with a high criticality. In medical devices, especially rather than in refrigerators, this might pose a risk to patients and also for the environment. So meaning, for example, for the hospital. It is therefore crucial to assess not only a single product, but all communication and interaction and all trust relationships in a whole system. So within the project, here is an example for a patient monitoring system that we assessed. We could compromise such a system. We could tamper vital data measurements as well as the data communication flow. In this schematic drawing of you can, I think, see it already complex patient monitoring system. I would like to show you what are actually the assets, what is problematic, and basically on the left side where you see two patient monitors, number 1 and number 2, this can be extended up to thousands. So we reduce the complexity here already. Here in the schematic drawing, dashed lines represent interactions with users like nurses, doctors, physicians, admins, and patients. But here the patient cannot directly interact with the monitor. So the monitor is used to measure vital data. Such system consists of, as I said, multiple monitors up to thousands for example, in a bigger hospital, central stations, surveillance stations, and also connections to further systems in the hospital network like patient data management systems. What you see here is a high complexity, the hospital network is used, and I think with respect to the previous slide, it is really important to have a clear trust relationship among all communicating parties. Coming to the next example, which is another complex system that we also assessed, an insulin pump. This insulin pump can be controlled via an app via Bluetooth Low Energy. So instead of the pump as the central component of the therapy system, here the app is the central component which can remotely administer, or via Bluetooth Low Energy, administer insulin boli. Here, mostly the patient himself interacts with the device, as you can see via the dashed lines. In the project, we could hijack such an insulin pump and thereby administering insulin boli remotely. Now I will hand over to the technical part.
Thank you very much. To demonstrate the complexity and assumptions that may lead to vulnerabilities, I am presenting a vulnerability we identified in Project ManiMed 2. CVE 2020-27260 is about a health level 7 version 2 injection we identified in a patient monitor. So what is health level 7? Health level 7 version 2 is a standard which is common and also text-based interoperability standard for health and medical transaction-based medical systems and devices to support hospital workflows. It was released in 1989 and defines a series of electronic messages to support administrative, logistical, financial, as well as clinical processes, therefore enabling interoperability of heterogeneous medical systems, which means basically different manufacturers create products that are able to communicate when implementing this standard. As a result, of course, the majority of manufacturers integrate such interfaces just to bring their devices on the market and enable them to actively being used by the healthcare delivery organizations. So consequently, agreements on the message structure and content representations are required to pass and process the message's contents. The figure shows multiple patient monitors that provide further medical systems with data through so-called communication server, which translates the different dialects of the standard between the systems to enable a proper parsing of the message's contents. So in addition to the complexity of the system we saw in the first example Dina presented, there's also a complexity in the protocols on each connection between the systems. So you add complexity to complexity and get out vulnerabilities. The health level version 2 messages make use of an encoding syntax based on segments, which are basically lines and 1-character delimiters. So the target of evaluation was a patient monitor and used the message type ORO-R01, ORO-R01, which is somehow special, and we will just call it ORO, which means unsolicited observation message. So this message is used to transmit observation results from production to ordering system, which means, for example, from a patient monitor to a data collection system or patient record. The encoding characters are special characters and constitute the structure of the health level version 2 messages. So what did we manage in this case? Attackers with physical access to the device could inject valid segments into these messages with a connected barcode reader. So why did we need a barcode reader to inject? Because it's a funny image to see attackers scanning barcodes to attack systems, I think. But in this case, the user interface of the patient monitor denied entering these delimiters. So they filtered them basically and didn't allow from the touchscreen UI to enter them. So there was a possibility to scan input using the barcodes. And basically we just printed out our payloads and scanned them as they weren't filtered in this way. So we just needed this barcode to circumvent the restrictions on the special characters in these input fields. Normally they are intended to scan patients' personally identifiable information, which are basically labeled on the patient record, on the paper record, or for example, on the patient's bed, there is this barcode to have medical staff easily identifying the respective patient laying in the bed and accessing his data and easing the clinical processes, for example. So having this payload, what is it basically doing? It's adding a DG1 segment, which basically is a diagnosis code in a medical coding system. So when we inject this prepared payload, we can see for the following communication in the network, which is in plain text too. So just ignore the plain text. This is another thing we could also need to discuss with the manufacturers. But as the figure shows, our payload we had underneath basically injects the ERNW new line, our new segment, and another new line. So we basically just added this new segment into the message. And well, what it is basically doing? The following figure shows also that the message is dissected, and the previous figure also showed that the server was able to pass, process, and also acknowledge the message, so it's valid. It's not rejected by the server. So it's parsed, and we can see that the diagnosis code basically is accepted by the system, even though the patient monitor doesn't normally really publish diagnosis codes to network connected systems. So basically we managed to inject an arbitrary diagnosis into the patient's record. That's for the example at this point. So basically what is important when testing medical devices? So let's get one step back. The fact that reality in the operational environments deviates from the original assumptions can result in vulnerabilities. So for example, the manufacturer of the medical patient monitor didn't assume that medical users would try to inject segment characters via barcodes. And as a consequence, not individual components, but complete systems should be considered. So the manufacturer may have assessed his product, but didn't see that medical record systems basically are processing these tempered messages and what the impact in these systems is. So there is, of course, a trust boundary that can be exploited in this way, and also in this example. So as a consequence, not individual components, but complete systems should be considered, which allows a full view on all IT security relevant interfaces, functions, and mechanisms. These include, of course, all wireless and wired interfaces, such as Bluetooth, Wi-Fi, Ethernet, USB, serial, and yes, you will also see infrared interfaces. Furthermore, mechanisms regarding authentication, update, and maintenance are, of course, relevant. In addition, for example, the existing security measures of particular interest with regard to the testing of the effectiveness and completeness of these measures. So in the patient monitor example, the measures were in place, but they were not effective using another way to bring in these payloads. So this makes clear that the testing is complex and should be comprehensive in order to obtain the best possible picture of the behavior of the medical device system. This is particularly important since different groups of people can use a medical device in different operation modes, which basically means that besides the intended purpose of the medical device, this is, for example, also patient-specific configuration or the technical service operation mode. In the example of the insulin pump, the medical operation mode by the intended purpose is of course the delivery of insulin. So an insulin pump needs to deliver insulin, obviously. And the patient-specific configuration would be, for example, the configuration of the basal rates, which means the insulin which is delivered per unit of time, so that you get a continuous delivery. And the technical service operation would be the import of firmware updates, which not necessarily has to do anything with the medical operation mode directly. But in fact, they are, of course, very closely related to each other. And I would hand over to Dina again. But first, let me clarify what is important when vulnerabilities are found. So when the assessment is performed, you basically will every time identify vulnerabilities. So it's in particular important how you handle these vulnerabilities. So there are, of course, different strategies. And we also identified these or experienced these different strategies during Project ManiMed. So not all vulnerabilities are equally critical. And therefore, prioritization and remediation always take place after the risk analysis was performed. And this can also result in vulnerabilities being accepted. So you have to keep in mind that maintenance windows must be set up due to the special operating environments and products. So not unnecessarily disruptions of medical care can happen. And also in the current state, only vulnerabilities that have an impact on the patients or may pose risk to patients are regulated in detail by law. So without this risk, you do not necessarily have the obligation to handle these at all.
Yeah, thank you very much. So a quick conclusion, so a wrap up from what we just said in brief. So what is your takeaway from our talk? And here is your cybersecurity to go. So we found more than 150 vulnerabilities in total. That might sound a lot, but it's with vulnerabilities, it is a matter of exploitability and not solely their presence. As Julian said, not every vulnerability is critical. Some can be accepted because the device is still functioning and saving lives, and this is what the device is used for. Yeah, a proper risk management and a proper risk assessment by the manufacturer has to be performed at all time to really get this feeling for vulnerabilities and to know what is going on. So we could only look from the outside on the device. We need manufacturers because they know what they have built. So we could only find this high number of vulnerabilities because the manufacturers provided us with the devices and the infrastructure components, and they had the will to cooperate and the will to improve on their IT security posture. We only had one device, an insulin pump, which had the potential of patient risk. All the other or most of the other vulnerabilities affected the infrastructure and not the devices themselves. So in the near future, maybe I'm addressing more or less the authorities and manufacturers and users, we should think about all the existing legal frameworks and standards and adjust them to our current and our future needs. So digitization will go on, also in the field of medical devices. We should all work together because digitization cannot be done alone. So most of the vulnerabilities identified in Project ManiMed are fixed or mitigated. Due to our coordinated vulnerability disclosure processes, we also involved other authorities like CISA and FDA. And here are some of the advisories that we could already publish, but there will be more in the next month because not every vulnerability disclosure process is yet over. So if you are interested in the project, please visit our website for an English or a German version of our report. And for more information, please visit ERNW's website. And you will find blog posts, white papers, and further information. We are available in the chat now. We are happy to take all your questions. I guess there are some, and you can contact us on other communication ways like via email, via Twitter, and so on. Thank you very much for your interest, and thank you very much for getting the opportunity to present here at HEK.SI.
Thank you. We got one question in the chat. From Thomas Weber, have you tried to emulate firmware of the devices?
We did not try to emulate the firmware as we basically were really limited in the resources we could spend on the tests. So yeah, assessing 10 devices needed to have some time framing, and basically this reduced the time we had to just have a look further at the firmware images. But mostly the manufacturers provided those, and they were kind of part of the assessments too in the special cases, which are of course outlined in the respective reports and blog posts.
Thank you. So if we receive any questions, we will forward them later to you. Thank you. Our next speaker is Stefan Janković, ethical hacker and penetration tester from Serbia. He holds certificates, certified ethical hacker, computer hacking forensic investigator certification, and CompTIA Security Plus certification. The presentation will be pre-recorded one with the title Dark Web. However, Stefan will say a few words at the beginning. Stefan, the floor is yours.
Hello. I don't have so much time for this presentation because this area is a big, but I speed up my video and you will see. And sorry if I miss something.
No problem.
Yeah. Okay. And
let's start. How to download Tor, and after that we install TailOS Linux. For best Linux for security is CubeOS. I will use VMware. Just follow my step. Debian. Not so much. Memory. Just next. This is the best environment for security on dark web. We now see what is basically what the deep web is and what are difference between deep web, darknet and the web. The deep web, invisibility web or hidden web is part of WWW or World Wide Web. Those content are not indexed by standard search engine. For any reason, it estimated that the deep web make up 96% of whole internet. The term deep web and the dark web are often used interchangeable, but they are not same thing. Deep web simply refers to anything on the deep web that can be found using a search engine. Difference between clear web and the deep web. And the surface web is every site we use every day. For example, YouTube, Google, Tesla, Wikipedia, Bing, etc. Anything you can access through browser. The deep web contain things that are private or anything that has security or authentication to access, for example, email, Dropbox, social media information that cannot be accessed with web crawler. The dark web contains things that are purposely hidden, not necessary for security, and request special software to access. We need the Tor browser to access darknet because those are basically sites that are purposely hidden, so that basically you can't index them with a search engine on the deep web and the surface. We basically interchange those two terms together, but in essence they are the same because they cannot without Tor. The Tor is a relay of network that we're going to use to connect the deep web. Tor is onion router. Tor is proxy system, a series of proxy that used to anonymize communication over the internet, so encrypt data using the onion routing system, which is basically a layer of proxy that will shield you basically your traffic as you browsing on the deep web or darknet. That is the difference of the white net and darknet. Now I will show you myth breaking on the dark web and deep web. Who have a time to stop and read text because it is long and I don't have a time. And now I will show you dark web. Some site, but not all. I think I found something. And when you go into dark web, you always close the Java and use full screen.
Pustili moj video. Da se mora da se javimo i posle sad na početku i na kraju opet sa kamerom za to. Super, onako malo mi se uplaćuje puno ljudi, onako preko 50 čoveka i to. Da. Sramota, ali da.
How to access on the dark web via Android. First, download Ortbox. Ortbox is created by Tor project, and it is official and absolutely free. You can go ahead and install it. When you install the browser, open it and hit start. This is second Tor browser. You can also try. When you install, tap start and you can change language. You can also change the location for your Tor VPN. Above will write you download and upload speed when Tor is run. We are now searching and change the security aspect. Now you see blank screen, and that is Fox browser does not allow screenshot or recording. But I have another technique how to record. And that's it for Android. We are now we are going to start with creating and hosting your own deep web and onion website. using a Linux distro. Your PC will be a server and don't will be a Windows, trust me, because of security issues. You first must install a Tor and install Apache 2, update and upgrade before start. Now I added something in Tor. We must add a hidden service dir, that is var lib Tor and hidden service, that is creating a new directory. And then hidden service port 18 and your ipconfig. Find your IP address and add that. After that, we'll start Tor and Apache. Now we use Nautilus command in terminal and going to File Explorer in our hard drive. It's Corona time. And now we are going to var. After that in a library. After that in Tor. And our directorium is hidden service. In Tor directorium. Open file. That is our host name. Copy that. Yeah, and we have a web HTML, but that is for web development. Our host name based on a Tor browser, and that is our site. So easy. Now we will see it is our site is up. Yeah, that's it. Who is web developer, he know what to do now. What is Bitcoin? Bitcoin is a consensus network that enable a new payment system and a completely digital money. It is the first decentralized peer-to-peer payment network that is powered by its user with no central authority or a middleman. For a user perspective, Bitcoin is pretty much like a cash for the internet. Most preferred for payment on the dark web. It is preferred because of its anonymity capability. What is a Bitcoin and how it used? Bitcoin is a digital currency created in 2019 by a mysterious figure using the alliance Satoshi Nakamoto. It can be used to buy or sell items from people and companies that accept Bitcoin as payment, but it differs in several key ways from traditional currency. Bitcoin terminology. Wallet, where Bitcoin will be stored for later use. Bitcoin address, an alphanumeric key that will be used to send and receive Bitcoin. Blockchain, a list of blocks that have been mined since the start of the cryptocurrency. Atom, a location where you can buy Bitcoin with real cash. Bitcoin mining, generation of Bitcoin in exchange for solving cryptographic problem using computer processing. And now value of Bitcoin is abnormal. And next site, I will show you where you can buy or sell Bitcoin, and I think this is official site and legit for now. In the next future, I don't know. Welcome to PGP. It is a type of encryption that will allow you to send message across the internet or even the deep web. Today I will show you how to use on a Windows OS or operating system, and let's go started. Today I use Cleopatra PGP, and this software is available for Linux and for Windows. What is name PGP? PGP is a shortcut from pretty good privacy, and it is the way to encrypt message online, used to encrypt text, file, email, or etc. It is used on dark web for share information and sensitive privacy, and used on military ground encryption. In next picture, we will see example of public key and private key. Public key is for sharing, private key is not for sharing. And no one must know that. You have a sender plaintext encrypting with public key on clipper text, and decrypt with private key. Now I will show you. I use Cleopatra, I said before. This software is make my private and public key, and you must know to understand that what is public, what is private. Listen. we set expire datum kad ističe experiment date, and now we use our super strong password.
Stefan, you should slowly finish the presentation because the time is running out.
Now we make public key. What we need for decryption, sorry, encryption. Yeah, we see example. Now this is our private key, and no one must know that. After this is only for you. And now I will show you how to encrypt and decrypt message.
Have a timer.
We see encryption message here. Now we will decrypt. You must understand that for encryption we use public key, for decryption we use private key. That is the difference from public and private. Now example of decryption. Easy peasy. Lemon squeeze.
Okay, Stefan, nice presentation. I see there no commercial pop-ups in that.
Yeah.
So only information you need.
Yeah,
okay.
But little time for finish this.
Thank you. So we move to the next speaker. Tomislav Gotovac from CARNET, Croatian Academic and Research Network. He spent more than 15 years in the IT industry, gaining invaluable experience in various infrastructure and security departments. After several years in pharmaceutical and fintech industries, he joined Croatian National CERT and its services and infrastructure security team in 2019. His presentation will talk about community-powered IP reputation system. Tomislav, the floor is yours. We see the presentation, it's fine.
Okay, do you see it?
Yes.
Okay, just a second. Okay. Thank you for the introduction, Andrei. Hello, everyone, and once again, welcome to HEK.SI conference. As this is a security conference, I'd like to use this opportunity to help save many of my fellow colleagues from danger lurking on Sunday. If you ask what's on Sunday, it's St. Valentine's Day, and no matter what kind of pact you think you made with your better health, just buy something nice. Even flowers will do. Okay. Now, after a month of thinking about this lecture, I decided to tell you a little story. I started my journey in an American pharmaceutical company. One of those is somewhere in this picture. American, in this case, meant they had to be SOX compliant, and American pharmaceutical meant that they had FDA breathing down their necks all the time. My first boss taught me one thing, and that's when we are under audit, we must give simple answers only, and the auditee or the person being audited should not in any case go deep on a subject, and better yet, not even go shallow, just provide simple, superficial and short answers, which do not discover much information or create window for additional questions. So I took his advice on my further journeys, and my next stop was payment card processor and the PCI DSS compliance. Their internal audit department was really not fond of me. So our usual talks would go something like this. They would ask, do you patch your servers regularly? And my answer would be, yes. Do you keep time synced to NTP? My answer would be, yes. Do you have file integrity monitoring and CM agent installed? I'd say, yes. Can you tell a bit more about it? I'd say, no. I kept my promise to him even to this day, but as I said, it always got me into trouble with internal audits. However, there was one specific audit which imprinted in my brain, and it was related to usage of open source applications in enterprise environment. The question was roughly, can I be certain that new release of application, which is published on its official site, is clean and not altered version? Now that question pretty much raised my nerves. It kind of offended me also, as I took it personally, but I answered in my usual style. Yes, I do. But I lied. I couldn't be certain, and that's something I never admitted to anyone. And why am I saying this? Because I guess you all remember NPM modules infected by malware. First time I paid attention to this happening was in 2018, when it seemed that 14% of modules was compromised with roughly 50 million or so impacted module downloads per month. So I wanted to see if it is still happening, and it seems it does. And it seems it's quite often, because maybe the reason lies in statistics, which says that over 600 authors on the NPM repository had password 123456, and over 1,400 authors had used their usernames as password. So that's just not a good security practice. It seems that not only open source repositories have their set of problems, it seems that commercial ones do too. So let's remind ourselves of SolarWinds attack, the recent one that happened as a supply chain attack, which made public on December 13th last year. Please note the underlined sentence, compromise of the Orion software build system. So this really can happen to everyone, not just in the open source, it also can happen in commercial entities. 2020 was unbelievably awful year to many. Among many things, who would think that contract clauses related to force majeure would ever be activated and called for? So we all know force majeure means war, strikes, riots, floods, epidemic, pandemic, devastating earthquakes, and we had many of those in 2020. Now, on early Sunday morning of March 2020, whole city of Zagreb was waken up to 5.5 earthquake. I was digging for information on similar earthquakes in Zagreb, and it turns out that such a destructive earthquake has not been seen in the last 140 years. It was in 1880 in Zagreb, and it severed half of the city, which then had approximately 30,000 citizens. Archives also claim that in the period from 1911 until 2020, there were no significant devastating earthquakes, and those are between 6 and 8 on MCS scale. But the records say that from March till April 2020, there were around 146 earthquakes that hit Zagreb. After it all stopped, they faded. Most of us got through without damaged homes and mostly forgotten about it. However, after that, it was all COVID this, COVID that, and the usual subjects in public. But then came December. Christmas is just behind the corner. Social life really doesn't exist. We are mostly or completely working from home, and just keep hoping that 2020 will end without a zombie apocalypse. But no. Right when we thought that the hellish 2020 was over, it had given us all of its worst. The second great earthquake, which was originating in Petrinja, and it was 5.0 on 28th of December. It was the beginning of bad days for Petrinja, because then, just 2 days before New Year's Eve, came second devastating 6.2 earthquake, and this time the situation in Petrinja and surrounding villages got inexplicably worse. This earthquake did things to Petrinja and Sisak what my kids usually do to their Lego blocks. Okay, so really, the year started with an earthquake, it ended with an earthquake. I was afraid to ask what's next, until I saw Bill Gates announcing 10 times worse pandemic than this one coming, and he totally took out the surprise. But he also says we should be preparing for some kind of a war. Now, related to the earthquake in Petrinja, let me just point out, this is a historical diagram of earthquakes during 1 month following 28th of December. A series of earthquakes, and by calling them a series is an understatement because there were 620 of those during just 1 month. And I don't know if it's impossible or improbable, but it definitely is unexpected and a high volume. What does this all mean? We all know that earthquake is now, but what we don't know still is when, the location, the scale, the duration, and the consequences. Consequences, however, are something that's immediately visible after earthquake strikes. And this is something that takes us to earthquake do's and don'ts. As every process of building has best practices, I compiled a short list of do's and don'ts when building a house in a tectonically live area. This was scrubbed from several sites which followed this subject thoroughly, and I'll name them, the most common ones. You should have sound foundations, keep your building as symmetrical as possible, and use beams and columns made out of reinforced concrete. It's kind of simple 3-point idea, and you would think that people follow those suggestions. Let's see one. This is an example of actual house somewhere in Zagreb. And this one also near me, where I live, but it looks like my kid built it in the Minecraft game. So, what is the point after all these rants about an earthquake? Is an earthquake similar to our business? I believe so. Because if you build your infrastructure the same way as those people build their houses, you're on the same way to hell. Okay? As I've already shown, these are the things which are unknown to us before the earthquake. And I believe it's the same with cyber attacks. Many companies hope that the great misfortune will happen to someone else. And if it ever happens to them, they will sort it out somehow. And it was the same kind of principle they were applying when GDPR came on stage. You know what, we'll cope with it, we'll do something, we'll deal with the inspectors, and etc., etc. So they willingly accept the maximum risk, thinking that its probability of occurrence is low. But as we know, cyber attack is not a headache for which you just take a pill and it goes away. It's deeply disturbing to every business, with, of course, possible serious consequences. We've seen in slides before that authors of NPM modules use 1, 2, 3, 4, 5, 6 and their own username as passwords. And as unbelievable as it may be, those brute force attacks succeeded after all. And in general, as they are low probability, they sometimes succeed. Let's remind ourselves what kind of brute force attack we have. So these are the usual ones, and the point of brute force attack is to discover credentials and access unauthorized content or assets through the weakest link, such as username and password combination through various methods, rolling dictionary words, use pre-compute hashes, use common password and try a multitude of usernames, etc. There are many ways of brute force attacks. But dumb brute force attacks are always logged in your system of choice, in your CM of choice. And you never mind if it's someone trying to guess password for user Joe, though he may not exist as a user on the system, or someone is trying to pick and pull through potential HTTP paths or something. Some administrator somewhere may be your loose end. Though we say that end users are loose ends, sometimes even the administrators are. Let's for a moment say that we are running VPS on, for instance, DigitalOcean, Rackspace, HEK.SI, whatever. Provider generally will not be interested about malicious actor trying to brute force his way into your server. However, once adversary succeeds, they suddenly start caring and they start complaining when your server gets compromised and becomes the source of malicious packets to other 100 or 1,000 locations all over the internet. So who is responsible, you ask? This is your mess. No matter how you look at it and who you blame, it's always yours. You have to clean it up. Now, as Linux is the most common choice for a server, I believe we all agree that this is a large attack landscape. Okay, this presentation is about those 96.3% of Linux servers which are exposed publicly, and a great percentage represent shared hosting servers, dedicated servers, virtual private servers, or even exposed containers or databases. Now we are in an era of cloud computing, but it doesn't mean that your local network is safe. There are still plenty of users, partners, and vendors inside your network. During COVID, the situation got even worse as a large number of companies exposed their remote desktops directly to the internet, instead through the VPN or RDS gateway. Why? Well, probably because they were not expecting it, never prepared for such a scenario, and management demanded a solution immediately. But even if a remote workforce is connecting to company VPN, it's their home, which is their home network, which is also becoming liability for the local area network of your company. And it should also be taken care of, because our infrastructure might end up looking like this. For your information, this is an actual house I have to pass by every day I go to work. So I admire it always. And if you missed a few slides earlier, I think this house excellently represents most of usual infrastructure today. Now let me explain. We may have sound foundation, as this house does, because it's standing on a hill. Conventional ground floor represents our common services, which are mildly updated to reflect modern business. But then we have first floor, the one with the balcony, where new technologies come in, infrastructure is rising, and we suddenly have new ways of doing things and end up with BioDs, cloud technologies, hybrid infrastructure, containers, orchestration, automated deployments, automated builds, public code repositories, etc. You know, I could go on indefinitely, but then we start making shortcuts and forget to include security not only in early phase, but completely, and then we end up with a Frankenstein monster. Let's get back to the brute force protection. There is no universal solution to solve all our security problems, because we are really never secure. Day in and day out, there is always one hole that seems to be forgotten. we are using our usual set of protection layers like firewalls, hardening, service isolation, network separation, but we have to ask, is there something else? So let's Google it. It seems that 4 out of 5 results will suggest fail-to-ban as a solution. I could not find details on how many fail-to-ban installations there are, so I can only assume the numbers. Fail-to-ban, a little history on it, is a way to protect brute force logins, directory listings, aggressive scans, and it's usually detecting repetitive patterns and acting upon those. It's a great tool for aggressive abusers on the internet, but after 16 or so years, things changed. Today we have technologies which were just a theory even 5 years ago. There are some other solutions such as OSEC or its fork Vazuh, which in essence provide the same services fail-to-ban. It will block persistent IP, which is failing to, for example, authenticate properly. But in the end, all that information about blocked IPs will be local to environment, and any new appearing IP will have to be watched for again and again. And I believe that there is a new approach, a better approach to this problem. It's a solution called CrowdSec. And as website says, CrowdSec is a free and open source security automation tool, which is leveraging local IP behavior detection and community-powered IP reputation system. Before I go any further, I want to note that as IP is classified as a personal data, the link here contains all the relevant information regarding the CrowdSec and the treatment and their treatment of aggressive IPs. And please check if you find joy in reading privacy policies. Now, a short history about CrowdSec. It had its first release candidate in July 2020 and the version 1.0 released in November 2020. So this is just 5 months after the first release candidate was published on GitHub. It generally follows fail-to-ban idea, and the logical question appears, so what's the difference? As it follows fail-to-ban idea, it shares basic functions with it. It's analyzing logs and evaluating IP behavior. But the similarities end there, because CrowdSec is able to check potentially offending IP in IP reputation database, and it has options to present additional security layer in form of CAPTCHA, two-factor authentication, or just simply blocking aggressive IP address. But I believe that ultimate feature of CrowdSec is sharing of a bad actor with, IP with the community. And let's see what CrowdSec ecosystem is made of. So it has agent, which is the first point of contact with your logs. If something suspicious is found, it forwards the information to CrowdSec bouncer. These, which are able to perform any of aforementioned scenarios. All CrowdSec components, the agent reading the logs, the CS CLI for human interaction, and the bouncers communicate between each other via REST API. So only the local API service interacts with the database. Database support is SQLite, Postgre, and MySQL. This getting easy on the database approach allows for greater scalability, distributed setup, and multi-tenancy, which is announced as a soon-to-come feature. Now, the general advantages are easier installation and maintenance with no special technical skills required. The installer comes with a wizard, so it's pretty easy to install. It's designed to be integrated with other solutions and automatically block attackers and informing your CM. Metadata about the attacker is sent to central API, and when attacker is confirmed, the malevolent IPs are shared back with all users in the community. It's lightweight, as it's written in Go. It can work with call logs also, and it can be used with many different bouncers to reply in the most appropriate way. So I have 3 more minutes before the end, and it's time for the demo. I'll just try to share another screen. Andrei, can you please confirm that you see this screen?
Yes, we see. Yeah.
Okay, great. Now let me see if it died. Okay, so this is the dashboard that's active as a Docker container on the host, and it consists of three parts. This is the main dashboard. The third one, the alerts history and active decisions list. We'll start with active decisions list and see that the SSH brute force is the most common on this server. This server was simply installed in Hetzner VPS. It doesn't have many services except Apache and WordPress. So we can see that there was some sort of HTTP probing, non-statistical crawling, and WordPress brute force. I'll just jump to our demo site where we can see a list of installed plugins. So CrowdSec installs as a plugin, and it has its own menu. You connect it locally to your instance of API. You have to register API key and decide what you're doing with bouncing. I'll get back to alerts history, and we can see that it does a thorough inspection on IPs, originating country, AES, network number, and what kind of attack it performed. 30 seconds to go. And this is the main dashboard where you can see all of the information, the number of active decisions. What I need to emphasize is that it also contains community IP blocked addresses and the ones which this server received. We can see all the countries originating. The darker one have more attacks towards this server than the lighter ones. So the China and surprisingly Canada are the worst attackers. There is a timeline for machines, what kind of attacks happen. So if you select this one, you should see the highlighted. Oh no, sorry, this one. You can see it. See the graph. You see this one. So okay, so you can filter it. I'll jump right on. You can see the source IP detection, which machine. The machine is not the attacker; it's the local machine who is reporting the attacks, and overview of how many, what kind of attacks were the most, and how many were other attacks were. This is the source by AS. We see China, and this should be Canada, I believe. And this is overview of the origin. So as I mentioned, this is the CrowdSec API locally on the machine, and this CAP is the community information received.
Tomislav, can you wrap up the presentation?
Yeah. So this roughly is a CrowdSec, and it's on a good way. I hope that it's going to be even better, and especially when AI jumps in, hoping that it will do something intelligent. Okay, that was it.
Yeah, thank you. So Tomislav, you have one question in the chat. So we are running out of time. So maybe if you just answer in the chat. So.
Okay, I'll answer in the chat. So.
Okay. So thank you.
Okay, thank you.
So our next speaker is Jan Marek from Cyber Rangers with the presentation Defense Evasion on Microsoft Windows OS. Jan, you can start.
Yeah, thank you so much. I hope you can hear me well.
Yes.
And so, yeah, let me share my screen. Just give me a sec.
It seems we lost the connection. Maybe you can try to reconnect.
Yeah, thank you. I got some, technical malfunction. That's typical. Sorry for that.
No problem. Can you try it again to share the screen?
Yeah, definitely. The case was that, when I touch my screen,
okay, now it's
I was
fine.
not able to share it. Yeah. So now I hope you can see my screen, and let's go ahead with the presentation.
Yeah, it's working.
Yeah. So thank you so much for having me on this special event. My name is Marek, and I come from CyberRangers, and I'm mainly focusing on red teaming, penetration testing, and a lot of different stuff related to offensive security. I'm a member of our red team, and our primary focus is to, let people know how to be more safe in this digital world and help companies to achieve more in a secure manner. And today I prepared a short presentation about Windows defense evasion techniques. I'm primarily focusing on Windows and Microsoft platform, specifically on Windows operating system and Active Directory. And today I would like to summarize some points that are quite critical for the infrastructures for the security. And all of these approaches I will be showing to you in this 25 minutes or 20 minutes are basically based on the insufficient level of security of the endpoints. And these days, a lot of companies are focusing on the advanced security techniques and technologies, and they forgot about the basics. Yeah, so definitely to have some, disk encryption in place, and not to use local administrator privileges on their business account, and use some application whitelisting technology, have control over their specific codes. At least at these days, when the PowerShell is, cross-platform and it's built into every supported Windows operating system. And after they implement those, basic principles and approaches on the technical level and on the process level as well, then they can, focus on the implementation of EDRs and so advanced techniques. And today I would like to, talk about how to evade those basic principles and to emphasize that they need to be implemented, together, and you are not able to secure your company, to secure your endpoint devices, to your endpoint, basically your computers and laptops, in the way when you just install the antivirus, or you just install or implement the application whitelisting features, or you just, migrate from password authentication to passwordless, and so on. So let's start with some topics. So first one is the disk encryption. So today, the disk encryption is when you use disk encryption with the combination with local administrator or least privilege models, so to avoid local administrator privileges, then you should be able to protect the computer against the offline attacks, basically. So if the user is not member of local administrator, then when he clicks or she clicks on something in the email, or approach or access some malicious website, then there is very low level of infecting the local network, because the only risk at this point, at this specific point, is only for the local computer. If the user is running is using the local privileges, local administrator privileges, then the case can be worse, because the vulnerability which can be exploited by some specific code on the website, or some macro in the Excel file, can call some privilege escalation features and then go ahead and try to replicate inside the network and so on. So when you combine the least privilege modules with the disk encryption, you should be safe, because the only way how you can access this system is to just stall it and then try to hack into the computer or get short time. It can be only the very short time when you have physical access to the laptop, and by that you are able to compromise the installed operating system. And the case these days is not about this encryption, because today we got a lot of technologies available for us for the disk encryption, for the real full disk encryption. But the case is how these technologies are protecting these decryption keys or private keys and so on. So the very key point for us is that we are completely sufficient in the offensive techniques on the Windows operating system that's not using the disk encryption at first. And the second is if the computer is using disk encryption with not sufficient protection for these decryption keys, so they are available in the memory, or there are no protection against the direct memory access exploits and so on, then the disk encryption itself is basically useless, because still the user, even if in the case it has local administrative privileges, then the case is that we are able to somehow get into the data, get into the computer, install malware, avoid antivirus, and so on. So the disk encryption is one big topic today, and it's not important only for the endpoint devices, but it's still important for, or these days even more important for server operating systems, and of course desktops, which are not being taken from the physical premises of the company by the users to home. So the first point. Second point is the application control. So if you have no application whitelisting, basically technology in place today, then your only security boundary is the antivirus, basically, or the integrated security features that are part of the operating system. And the application control these days can be used to even help you to protect against the ransomware attacks, because then you have control over the programs, codes, installators, and different executables, and you can say which is allowed and which is not allowed. And a lot of operating systems these days support these different application control mechanisms, and one of these is built-in feature into the Windows operating system. So the case is that in Windows 10, let's say, in Windows 10 operating system, you can have App Locker as a part of the operating system, as well as the application control, basically Windows Defender application control feature. And they both work very well. This App Locker feature is more targeted on the high level control of the application, and the application control should be used for the low level control of the executables, drivers, and so on. But still, in that case, if you just implement the application control itself and you just configure it using default rules or default configurations that are available in the operating system, then you can be in quite a big problem, because as you can see on my short demo, I got a computer which has some basic user logged in, and I got no specific or additional privileges. I'm just the local user on the system, and still I'm able to run some own crafted PowerShell script, which is not detected as malicious, of course, because this is something that's just taking care of ACLs on folders. And as you can see, on my case, I was able to find some folders that can be accessed by the user, and I got right permissions into these folders. So if there is either insider in this case, or if there is malware that can do the same enumeration, then it is able to copy some specific code. At this example, I'm trying to run Resource Hacker, And when I just copy the file into the right directory, then I'm able to run it, yeah, because these folders are at first writable for my account, and second, these folders are part of the default rules that basically say these folders are contains applications that are allowed to be run on this operating system, and it's typically C windows, and it's typically C program files, x86, C program data, and so on. So even the user with this, default rule implemented in case of AppLooker is able to run some specific, either tool or some specific executable that can be malicious for the network. And this can be a very interesting approach for the ransomware as well. So a lot of time when we are doing, red teaming in our customer side, then the case is that, okay, we can see that you got the application whitelisting feature implemented, but do you take care of these default rules, and do you take care of these specific folders that the user have access to? So this is the first point, or the second point of my presentation. The third point is the privilege escalation. So there are multiple approaches how you can escalate privileges. The most used basically, scenarios is to use some vulnerability in the specific application or software that's being, run on the corporate network. So for example, like 1 month ago, we faced some issue with one of our customers that have the Cisco VPN client implemented, and there is a privilege escalation vulnerability. So basically, if you got the user access, then you are still able somehow to get the elevated privileges on the system. So in that case, it's very critical for the company to take care of the centralized installation of the software, have the inventory, take care of all software that's been run on the system, and regularly update those applications. And of course, use the application whitelisting features as well. And the other option, how to escalate privileges, is to somehow bypass the UAC dialog, which stands for user account control. And a lot of cases, administrator, personals are working with their privileged accounts on their management systems or on their endpoints, basically. And they use those endpoints even to browse the internet and even to open emails and so on. So in that case, they are protected only by the UAC. And they got some, basic understanding, then this is some kind of security feature that's basically helping them to be secure, even if they use those, privileged accounts. But that's not the case, because there are a lot of UAC bypasses, and there are a lot of automation techniques, how you can just trick the user to configure the operation, or just to, automate the escalation itself. Another case is to evade the antivirus, because today you got antivirus integrated into the Windows operating system as well. And so how this can be tricked, and I will not go into some technical stuff. I will just show you a very simple thing, which basically uses the, again, rules configured by the company. So as you can see on my screen, I got some, client operating system, and I'm just the, regular user, and I'm able to, basically see the exclusions that are being configured by the company, by the central policy for the antivirus. And that's typical configuration, because a lot of management systems and several services required to have some exclusions on the level of antivirus to be, to have better performance and to have, faster improvements and so on. So in that case, I got 3 folders, or at least 1 folder configured on my, specific system. And as you can see, I'm able to enumerate this information even as the local user. And then, of course, I'm able to take a look at this different configuration. This was fixed on the latest Windows operating system, because you need to be local administrator to see those exclusions. That's right. But still, you are able to, for example, combine those attacks together and have some privilege escalation. And then you are able to, enumerate those exclusions. So then you are able to verify if you have some write permissions into one of these folders that are being excluded by the antivirus. And then you can just download some, specific, even in that case, malware. So let's say ransomware jigsaw, or I just use different kind of samples in that case. And as you can see, in this case, I think it was Petya. And as you can see, the computer is basically down. Very simple case, no need to, work with DLLs and do some process hollowing techniques and so on. You can just see what you can do with these default rules. And the last example I was just to show you is log management. Log management is a thing that you definitely need to have, but sometimes the user is, or the attacker is trying to hide himself. And I got very simple POC over here, which is basically just showing the configuration of the local auditing on the target system. And as you can see, I'm not able to enumerate these information as the local user, so I need to do somehow the privilege escalation. But if I am member of local administrators, I am able to see that they are auditing the process creation and termination events. So in that case, I can have some, I can have some very basic script, but basically in that case, run just, I think it's ARP command. And because I split in like 100,000 of, these processes, like in parallel, then I'm able to basically overload the event log. So in that case, I can even delete the malicious activity from the log because I override the log. And the second benefit from the offensive point of view is that I'm able to overload the CM and the SOC team. So they are trying to find me what I'm doing because I'm running a lot of ARPs, but I'm working on a different computer at the same time because we are the team of hackers and so on. So definitely, if you are using some SIEM or log management techniques, don't forget to, configure your rules in a proper way. Otherwise, this can be, used against you. So that's all from my side. I would like to spare some more time on the questions if I have some, because this was part of my time. Or if there are no questions, let me thank you for your time. Have a great day, enjoy your weekend, and stay safe.
So there are no questions in the chat. Any questions from the participants? We still have some time left. No?
No questions. If you have any other questions, you can find me on LinkedIn or you can just send me email.
We just got the question now.
Yeah, that's Microsoft Security Compliance Toolkit help in some of the techniques. Yeah, definitely those security compliance toolkits or baselines can help you to implement that, and you can find a lot of stuff on the community pages on the Microsoft documentation side. And what I would like to recommend as well is the SIS baselines, focusing on the Windows hardening, or and to implement, for example, in the case of auditing, is to implement some kind of advanced auditing, not using these Windows features, but using, for example, Sysmon, which is free to use, and you can implement it very simple way and just use it. Yeah, so definitely security compliance toolkit and a lot of different baselines that you can find on Microsoft portal or on the GitHub, then you can definitely use that. No problem. Thank you.
Thank you. So we move to our next speaker, Nate Bijl, has experience in IT more than 20 years, and he mainly operates as an advisor between the executor and the client, so that the client gets what he really needs. So the last presentation has been pre-recorded. However, so you're welcome to leave some questions in the chat.
Hi, my name is Nate Bijl, and today I'm going to be talking about hidden traps of storing data in the public cloud. Before I begin, let me introduce myself. I've been dealing with IT technology since 2000, and I'm an entrepreneur, and I help organizations with consulting and training in the field of networks, devices, and software. With everything I do, I give a lot of importance to the field of information security. I also promote interesting, useful, and proven tools in the field of cybersecurity. So, if you are all ready, let us begin with the topic. When we are deciding how to store our data, private or organizational data, we face dilemmas. We are facing all sorts of scenarios, like where to put our operational data and backups to be safe in a matter of confidentiality, integrity, and availability. Therefore, we ask ourselves the questions like, what will be the cost? How much maintenance can we expect? In case of incident, how long will it take to complete disaster recovery? How is solution scalable? How secure it is? How much control we have over our data? Are my data confidential? How easy is to migrate from one solution to another solution? Should we use private or public cloud? These and more are questions we reasonably ask ourselves. Let us take a look at some advantages and disadvantages of public cloud storages. Disaster recovery is first advantage. By using cloud storage, you have an advantage of reducing the risk of system failures. Well-established clouds can offer a very robust infrastructure which has a high level of redundancy. The data is stored away from your location and are replicated to multiple data centers across the globe. The cloud providers can offer automatic backups, and you may even use public clouds for disaster recovery. Most well-established providers are part of the ISO standard for business continuity and can offer up to 99.9% uptime. Next advantage is usability. You can integrate public clouds into your ecosystem in various ways, with tools that came with cloud, or you can create your framework using API interfaces and integrate cloud directly into your workflow. As your data are located on data centers across the globe, you have quick access no matter where you are. Your data can be synced and accessed across multiple servers and devices. Next advantage is cost. Public clouds eliminates the need to purchase equipment or the space to house it. Public cloud subscription costs little to set up, and you only pay for resources you use. Your service provider handles maintenance, which is a fixed cost included in your subscription. All software updates are handled by your service provider, eliminating the need for you or your staff to perform upgrades. No internal servers mean you eliminate the cost of the energy required to run them. You only pay for what you use, which eliminates wasted spending on unused resources. Scalability is also an advantage. You have the flexibility to quickly scale up or down, using more capacity when you need it, less when you don't. That gives you a unique advantage over private cloud, where you can quickly happen that you oversize your infrastructure in case of growth. Security. Well-established cloud providers can typically offer better and more robust data security than individuals or small businesses. Big cloud vendors attract the world's most talented engineers and have the money to pay for large security teams and the best security tools available. Public clouds undergo penetration testing regularly and are held to tougher standards than on-premises solutions and private clouds. Some private clouds never receive penetration testing at anywhere near an acceptable level. Most data breaches are a result of human error. Cloud skeptics think that keeping their data in-house allows them to control it better, but really the opposite is true. Data stored in the public cloud is less likely to fall into wrong hands because of an employee mistake, so your data are more protected in terms of external access. Let us now take a look at two important disadvantages. The first disadvantage is data privacy. When you put your data on a public cloud, you have to trust your provider. Trust that they will do everything in their power that your data will stay private. But that is very hard to determine. You have to examine providers' documents like terms of service, privacy policy, and others to understand how your provider operates. But even that may not be enough. The providers often change their conditions. The second disadvantage is lack of control. The moment you put your data on the cloud, you start losing control. You're putting your data in responsibility to someone else. For example, if something affects your storage provider, like outage or malware infection, it can impact your data access. You will have to rely on the provider to fix the issue. Let's return back to CIA triad. We can easily say that cloud storage has a strong point for the availability of your data and even integrity. But what about confidentiality? Confidentiality may be the biggest concern for public cloud providers, and that is the part where things get interesting. There are three crucial points why this is such a concern. The first concern is provider's policy. I mentioned this before as part of the data privacy. Some providers have a concerning practice of sharing data or metadata with third parties. Therefore, when we do our research for choosing the perfect provider, we look at something that will reassure us that our data are safe and private. Usually, we search for statements in privacy policy and terms of service that give us confidence that we control our data. We are looking for things like implementing one or multiple standards that increase confidence, like the ISO 27000 family standards, that puts the provider through some independent security and benchmark test. We are also searching statements saying that they do not share the data with third parties. But the question here is this enough? How can we be sure that our data are not systematically analyzed or some metadata extracted? How do we know that some third-party organization cannot access it? Second concern is jurisdiction. I think this is the most giant trap of all. No matter what promise cloud provider made, they have to comply with local laws. In some countries, government agencies require reporting and data collection for all locations where a company operates, even abroad. For example, if you are familiar with Snowden disclosure, you know that USA government agencies use a framework for automatic data retrieval from all possible sources, even foreign. On top of that, the Foreign Intelligence Surveillance Court can give a gag order, so providers have to comply with data extraction, and in some cases must not talk about it. That is one of many known examples, and other countries do just the same. So why this is so important? You may say, I have nothing to hide, so why bother? Well, for start, different countries have different laws. By putting data into the cloud located in a foreign country, data content may violate their local laws, even if they do not violate your own. Other essential things at a situation where you are storing data related to your customers or business partners. We can keep going, but I think you all see the point. Security breach is another thing that can happen to the cloud provider. As anywhere else, even with well-established cloud provider, you are not 100% safe. Anytime you store data on the internet, you are at risk for cyber attack. This is particularly problematic on the cloud, where volumes of data are stored by all types of users on the same cloud system. The scary thing is the vulnerability to the DOS attack and the concentration of so much data. The single point of failure is the cloud. If something goes bad, it impacts a very wide group of people. It's easier to steal and disrupt in bulk. Although most cloud providers have strengthened security measures as technology becomes more sophisticated, so do cyber attacks. When cloud companies get the security right, and many actually do a pretty reasonable job, then hackers have to get creative to get to the data. For instance, instead of hacking the cloud, hacker will attempt to hack your account instead. Let's summarize. Public cloud can be a very efficient way to store and process your data and manage specific risk. We determined that the most significant risk are the provider's policy, jurisdiction, and security breaches. We realized that security breaches are not the only thing we have to be aware of. The provider's policy and jurisdictions play an essential role in lowering your data exposure risk. The question that follows is how to deal with those risks and at the same time keep all advantages of the public cloud. Is it possible? Yes, it's possible. The answer is straightforward: encryption. By encrypting your data with strong enough encryption key, nobody can examine your data. You protect yourself against provider and jurisdiction threat, and even against security breach, in a matter of data privacy. But not just any sort of encryption. You have to be careful. Cloud providers already offer encryption solutions, and they are stating that encryption of your data happens on their servers. Does it? How would you know? In reality, you do not. So what kind of encryption is sufficient? Sufficient encryption is the one that happens on the device you trust. How put that into practice? Well, it all depends on needs you are having. If you plan to use the public cloud as a backup, you can implement encryption at a single point. But if you plan to use the cloud directly, you will have to implement encryption on each client's device. The solution is a tool that combines the cloud's benefit and adds additional layer of security with encryption. By encrypting your data right on your device before synchronizing data with your cloud, you remove risk of data privacy. Let's look at what things proper encryption software should have. Most important feature is of course encryption of content of the files with strong encryption algorithm. The next and also important thing is ability to encrypt file by file. So each file is encrypted separately, which is much faster than putting data into encrypted archive or container. We also want that encryption is done before sending to cloud, so that your plain data never leaves your device. We also don't want that any external service is connected to encryption process, so everything has to be done on your device. We want that our encryption software is compatible with multiple cloud providers, So we will have various choices to choose from. We also want synchronization, which is a very important feature, so your data gets synchronized between multiple devices automatically. Another thing is collaboration. It's an important feature which will allow you to work in teams, securely and privately. Zero knowledge feature means that it doesn't matter what data you will upload or download. Your cloud provider or encryption software provider will have zero knowledge of your data content. Another thing which is very important too is that we want that our file name or folder names are also encrypted. So no one can guess what might be the actual content of the file. And also important thing is that encryption software can work on multiple platforms like Windows, Linux, macOS, Android, iOS. And the next question is, who would want such a software tool? The software which returns control of your data back to you. I would say everyone who use or will use cloud storage in the future. I made a research of which software has all the features we talk about. If you are already actively using cloud and not using encryption, I would strongly recommend implementing it. To learn more about the software and what is suitable for you, follow the link below. elegantHacks.com/masterthecloud. I hope you found this topic informative and it gave you another perspective on what alternative threats might be and how to deal with it. If you would like to know more, feel free to contact me on email. Thank you for your time.
Thank you. Nate Zbajel has also joined us later, so he's available for any questions. Maybe Nate, if you have anything to add to your presentation. Currently, there are no questions in the chat. Okay. If not, we are moving to the final session of HEK.SI conference, a roundtable focused on phishing attacks and other social engineering threats. We have a nice group of security professionals with us, namely Boris Mutina, Sozon Leventopoulos, Dominic Breck, Pete Finnigan, Matteo Cuscuza, Andrei Bozeanu, Nikos Benias, and Marco Hölbel. So maybe I suggest that you introduced yourselves at the beginning, just for the sake of the participants. Maybe Boris.
Yeah, hello. Can you hear me?
Yes.
Yeah, hello everyone. As Andrei said, my name is Boris Mutina. I'm from Excel Virus Free from Prague. We are doing actually the spam filtering solutions and email security in general. So I guess that in terms of testing the phishing, maybe I could add some 50 cents to what needs to be said. To the next, Pete.
Hello, yeah, this is Pete Finnigan. I'm in York in the UK. My area, if you've already been to my 2 talks in the rest of the conference, is Oracle database security. So I don't focus on phishing, but I focus on the data that the phishers want to get. So they generally want to steal data from big databases, identities and so on, banking, whatever. So I'm focusing on the back end side. So I can say something about phishing in terms of how you might detect if you're the back end database owner, how you might detect if the connection is somebody who shouldn't be connecting. So the front end stuff of phishing, I'll leave to the other guys. Thank you. I'm not sure who's next in the panel.
Maybe Sozon, if you start.
Yeah.
Sozon. Microphone. Microphone is not working. Huh?
Now it's working. Yeah. Can you hear me?
We don't hear it. It's very low.
Right. Now?
Now it's better. Yeah.
Okay. So yeah, I'm Sozon from Athens. I had already a lecture yesterday, so you have some bio from me. I was a military officer just a couple of days ago, and I'm dealing with cybersecurity and information security, both in military sector and in the civilian sector. And phishing is one part of, major part of cybersecurity, because it's the easiest way for someone to penetrate within an organization, a company, or even the military. So yes, we are dealing a lot with that. And next to me is Nikolaos.
Hello again.
We are here in the office.
Yes, Nikolaos Benias. I had a lecture today earlier, the third one or the fourth one, about phishing and how hackers exploit all the emotions that we all humans have in order to achieve their goals. I am also in the army. I work in the CyberDefence Directorate for 10 years now. We've seen a lot of things there regarding phishing attacks, especially. And my Master of Science thesis was about phishing, where me and another colleague developed a framework phishing in order to do penetration testings. Just for that, and of course provide some kind of training for people.
Thank you. Marco?
Yes, thank you very much. So my name is Marco Hölbl. I come from the University of Maribor, Faculty of Electrical Engineering and Computer Science. I had a lecture yesterday about pitfalls when applying cryptography into practice. My main research, I'm mostly concentrated on research, so also on research regarding phishing. We also have quite some, let's say, collaboration with other institutes and companies in regard to phishing attacks. And I'm also quite active as a digital forensics expert, so we also see a lot of phishing there. And I'm quite familiar with the trends on phishing techniques, how the phishing techniques evolve through time. So I think I could put value into this panel in regard to that. Thank you.
Thank you. Matteo? A microphone.
Oh yeah, thank you. Good afternoon, I'm Matteo Cuscusa. I'm an ethical hacker and a social engineer, and phishing plays a big part in my job because, yeah, especially nowadays, it's where most of the social engineering happens. Usually, I deal with simulated phishing for companies, and what plays a big role is dealing with emotion and the reaction of people. And that's how the skills in social engineer are very useful. And phishing attacks are becoming more and more common. I'm from Italy, and the last year we had an increase of 87% of phishing attacks in respect of the year before. So yeah, it's a huge topic, and it's very important to know what we are dealing with.
Thank you. So Dominique Brack, are you here? Dominique? Or Andrei Boziano? Maybe they will join later. We can start. So just a few words as an introduction. So phishing attacks, social engineering attacks are, as mentioned before, on the rise. This is not surprising because less and less common it is to find the technical vulnerabilities which are remotely exploitable. So systems are getting better and better. And why doing the hard way? So to try to hack, let's say, hardly breakable systems, if you can just ask the end users for access. So it's not surprising that phishing attacks, social engineering attacks in general are #1 attack vector today. So usually any attack starts with some kind of email or some contact to the end users, typically because nowadays attackers are not after the systems, but after the data. So information is what is relevant. So what techniques do attackers use in this respect? Any idea from your side? Just anyone?
Well, if I can start around on this, what techniques they are using. What we observed at Virus3 is that the phishers are trying to combine just a traditional phishing, like your mailbox is full, or you have to enter security code, or your bank account has been taken on hold or whatsoever. They start to use also the patterns of business email compromise, which means that they are taking a parts of legitimate emails, injecting these into the message body and sending to the victims. And this is sometimes pretty hard to catch, because most of the people communicate with the counterparts, and when they receive the email from the counterpart saying, please, I've shared on our SharePoint a document which you need to download, and then they are redirected to a login page, which is obviously like a SharePoint login or O365 login. They just enter the credentials there without even thinking that they are on the phishing site. So this is what we see in the past weeks and months, that it's not just a pure phishing anymore. It's a combination of more and more techniques. Also, by trying to delivering the malware, also some sort of blackmailing, creating the fear, uncertainty, or doubt of the users. This is what we see at the major scale, the combination of all possible techniques.
Any other thoughts?
Yes, if I may add, we are more and more witnessing that phishing attacks are less mass phishing attacks, but more like spear phishing attacks. So tailored phishing attacks, as my predecessor already told or has explained, that they always use also, they target the emotions like scareware, for instance. In the COVID pandemic, they use the COVID situation in order to get better results in phishing. But also, the statistics shows that about 95% of phishing is done over email. So from a very practical point of view, some years ago, we had an investigation, a forensics investigation, and we found out that most people still are vulnerable to classical phishing attacks. So they get an email with an attachment, and they open this attachment. If you have enough people to whom you send this attachment, of course, one will open that. And even though these people were beforehand educated that they shouldn't do that, they still do that. So I think the idea of maybe simulating phishing attacks to make people aware, or to show them what happens if you do that, is a good thing to do.
Yeah, probably, if I can add something, yeah, it's probably the only way to achieve some results. I see that the things that works the most are the ones that play in this period on the fear of people, especially because of the COVID situation. I've seen a huge increase in the phishing email regarding COVID situation, and especially regarding economical bonuses that are released from the government to people. So usually people are pushed to open the emails, yeah, because of fear, because of necessity, and this plays a big role. Of course, it would be necessary, in my opinion, for companies to be more conscious of these problems and invest more on teaching people what to do and how to understand when it's phishing. In my opinion, this kind of test, this kind of phishing assessment are still not considered that important, and it's wrong, because as we said, the technical attacks are lowering while the phishing attacks are increasing every single day.
From my personal point of view, I'm not investigating phishing, but I've noticed in the last year that there is a big increase in emails pretending to be about tax refunds, for instance, from HMRC. HMRC is the government for benefits and money in the UK. It's the department that deals with this. I've also seen from friends where they've come to me and said, my Facebook's been taken over, my Facebook has been cloned. And it turns out what they've done is they've had a messenger message on Facebook Messenger from somebody who they know saying, oh, look at this video, you're in this video, it's funny. And they click on it, and actually what it is phishing, and somebody has then stolen the access to their Facebook and taken over their Facebook and then repeated the process and sent the messages to other people. I mean, I was looking at that for a friend just recently, and luckily this friend asked me whether they should open this message, and I looked at it and said, no, definitely don't open it, it's been hacked. And I've also seen somebody mentioned SharePoint or something similar like Dropbox or Outlook 365. I see this quite often in LinkedIn as well. So in LinkedIn, I get messages from people saying, open this document on, it doesn't say what it is, but it's on Office 365. And it's clearly an attempt to get your credentials. I mean, I don't even have an account on Office 365, so it wouldn't work on me. But you have to be careful everywhere. It's not just about email. It's about social networks. It's even about the telephone. So there's a big thing in the UK where British Telecom are ringing people up, but it's not British Telecom, telling them their phone line's going to be cut off and you need to ring back straight away and talk to the finance department. And lots of people have been scammed in the UK through this. I'm not sure if that's classed as phishing, but to me, it seems to be the same. So yeah, I mean, sort of flavor of some of the things I've seen in recent times. So I think somebody else was going to speak just as I spoke.
Welcome, Dominic. I see you managed to contact us. So we are discussing techniques used by attackers for phishing attacks. So any ideas from your side, experience?
Yeah, Andrei.
Yeah, I do mainly phishing with my clients based on some professional tools to basically raise awareness. But I do see an increase in phishing emails, particularly now with the COVID-19 crisis. So they have all kinds of COVID-19 crisis flavor. So it's tax department, it's health department, it's your company, it's like maybe the insurance, it's workers' compensation. So all these type of things, but they do all have the same flavor, kind of inducing malware or attack your machine or credential phishing, which then can be used later. But there's a slight increase, but also you can observe they've been done much more professional. So like, you know, these old rules you have, like, oh, if it's an email which has no personal greeting in the email header, oh, then it's probably phishing, but that's no longer the case. So I just did with the high school students, I did a demonstration, and they took basically their policy about phishing, which had about 20 points, how to detect the phishing email, and then used one of those professional softwares to create phishing emails and distribute them. And I think about 12 points of those 20 were invalid. So I could greet them with their personal name because I was just going to the university website, digging through their names, getting their email headers and email domain, of course. So it has become much more professional, much more difficult to detect. And also, since there is pressure on people to react quickly nowadays, especially giving a reaction, react to an email, getting into action, serving somebody some information, it's much more hard to educate people. So, and the only thing there is going down the path of raising awareness with those emails.
Any other comments, Sozon?
Yeah. I don't know if you can hear me.
It's a very low volume. We can hear it, but it's not okay.
Right, now it's okay?
Now it's better, yeah.
Okay, great. So I will agree with all the previous speakers told and the methods, but I would like to take a bit from Nikos' previous presentation regarding the emotions. What I've done in Unit, in order to check about the phishing, about how easily it is to fish around people, I did a non-technical approach. So I said, I created a false audit, and there was one question around the middle mentioning, please fill in your password in the social media, so we can use advanced analytics and check if it's strong enough or not. And more than 50% of the personnel actually put the passwords inside. So because we are humans and we are driven by our emotions, it's very important for us to have in mind when we are trying to defend from phishing attacks, we have to have in mind about the emotions, about the anger, about the necessity for us to help others, about the trust issues that sometimes we face with others. So this should be our first line of defense, how to deal with emotions. And hopefully this Nigerian prince is not a real person, because then we will have a great problem.
Yeah, I think I just can chime in here as well about the trust, because I think everyone has seen these bad examples about phishing, where people have to be threatened, you're getting laid off if you click on these phishing emails. And I think that's very bad generally, because that's the biggest fear. If you do a little risk assessment when you do phishing with multiple thousands of people, what I do sometimes, you do have to do a risk assessment. What does it mean on the people side? Because they are intimidated, they are scared. If you do phishing and it's kind of contradictory, banks do a lot of phishing. I was really surprised because we have an offer for phishing. So I'm working with all kinds of organizations, but mostly banks, and banks are very regulatory, compliance driven. And people are there really afraid of, if I make a mistake, I lose my job. If I make a mistake, people lose money. So you really have to be very careful with phishing. So it becomes more of a gamification. Otherwise, people are just scared, delete everything, don't react to emails. And I think that's the worst you get out of people. So they're no longer helpful. One of the best, vices people have, being helpful, help each other, supportive. And if you destroy this trust in email, then you can, I don't know, in the future, email is trustless like other communication. And maybe all the communication shifts to some chat messenger type of stuff. I don't know. So I think the trust is really important for phishing or doing phishing awareness exercises.
Yeah, I can relate with this, especially so phishing attacks are now very commonly also connected to usage of trusted cloud services like Google Drive, OneDrive, Dropbox, and these are usually trusted on the trusted list of the companies. So most of the security solutions don't work on them. Any comments on this?
Yeah, I'd like to comment on this. This is actually an issue. What we discussed within messaging mobile malware and the abuse working group is, and we call it actually abuse at scale, because it's a really a it's a massive wave of attacks that are misusing actually the brands, quite popular, as you mentioned, Google, Microsoft, Verizon, whoever can even, Amazon, whoever can even host something, some sort of data, it's at a risk. On the other hand, there is a quite significant difference between the companies, how they approach this topic of being a part of the phishing scenario or attacking scenario. The point is that, for example, Google, when there is a misuse of Google Drive or shorteners, Google really approaches these things quite fast. When there is some sort of reporting, then Google takes it really down. But when we are speaking about other companies that are providing the URL shortening services, some of them do not react on any abuse complaints. So you have no chance really to take down the malicious content, and the malicious content will remain there unless really the destination address or the destination content after the shortened URL is not being removed. So yeah, abuse at scale is really an issue, and misusing really a trusted resources is really a huge issue. And I'd like to really give kudos to Dominic about what he said about that it's about gaining trust and having the trust, and that the email will be trustless. Well, there is a one specific point. Everything you do at work should be bound with some sort of process. If you receive a request over the email, that should be verified by the process. I guess Dominic knows the situation of the Swiss banks. Swiss banks are heavily under email compromised attacks every single day. They receive tons of emails from someone pretending to be a client in a private banking sector, which really there is no way how to defeat this but the process of verification, maybe calling the client. It's not a cold call, it's not sending SMS, it's just notifying the client in a different channel. Yeah, we have a problem with the possible attack on our side. Can you verify, is it really you or not? So thank you.
I'd just like to say something like Dominic said about banking staff and trust. I was involved with a forensic analysis of a database that had been hacked in a bank in London. And I was looking into this and trying to understand what's going on. And I said to the staff there, to me, it looks like over a long period of time, lots of people in different job roles are logged in as the same user. And they said, no, just forget about that. Just focus on this particular issue. And in the end, I persuaded them. I said, can we get somebody from this department to come and speak to us? So they won't speak to us. So in the end, I finally persuaded them that we would go and speak to this department. And when I put it to them to their face, what had happened is somebody had been doing something some months before this evidence occurred. And they'd done something wrong and they were threatened to be fired from their job. So the staff in this department got together and they all agreed they would all log in as one account. So therefore, if something went wrong again, then they wouldn't be able to sack the whole department because in their view, they wouldn't be able to tell who did it. This is like, there was a lot of different issues in this particular case. You know, how were they able to do this in the first place? Because they should not have been able to all log in with the same account. We looked at that and fixed that, you know, but it was a case of mistrust of the staff of the organization. They were in fear of losing their job if they made a mistake. I mean, it wasn't phishing, but it's very similar to what we're talking about here. If you don't have the trust of the staff, they're not going to take anything else seriously. And, you know, another point that Boris just made about process, this is something I try and drill into people all the time in terms of Oracle security. You need a process, particularly around things like movers, leavers, and joiners. In most companies I go to, there is no movers, leavers, and joiners process for the Oracle database. You know, and the process generally to get a new account is somebody sends an email to the DBA. You know, and I've seen cases where this has been abused, where a developer has sent an email to the DBA saying, we need another account based on Mrs. Jones' account, same privileges, just send me back the details and I'll pass it on. It's phishing in a sense, because that wasn't a real end user who needed a database account to do whatever they needed to do with the database account. And I see a complete lack of process in around databases and managing databases. And this is where the data is. This is the data that people want to steal. So it needs to be taken more seriously. Sorry, thank you.
I think that,
yes.
Can I add something?
Okay.
Yes, I also have a very similar experience as the colleague before me. that for instance, in a company in Slovenia, they've done some phishing campaign, they phished username and passwords, and at the end they were able to do some bank transfer. Why? Because people didn't stick to the process. They left their computer on, they left their smart card in the card reader all night long, all weekend long. They use the same credentials, 5 people use the same credentials, and similar scenarios. So at the end, and another very interesting fact we have encountered is that people send emails, phishing emails with malware usually. They use this malware to gain a remote access, but because the attackers wouldn't like to use this, let's say, dark web tool, they've simply installed TeamViewer on the machine and use this TeamViewer to steal money from the company, and nobody in the company noticed that TeamViewer was installed on their machine. So it's interesting regarding the process or a standardized process or whatever process you need to. I think one of the key challenges here is to let people know that they cannot skip the line, as maybe in some analogy speaking. So they need to stick to a process, even if a CEO comes to the database administrator, for instance, it was mentioned before, then he can just simply say, hey, please create me an account, give me all the privileges and give me the logins. No, you have to stick to a process.
Yeah, I think what's interesting with the procedure.
Before, yeah.
Excuse me.
So you wanted to comment something?
Yes, but okay. It's, I would like to point out the significance of in and out processing. In the military and especially at the NATO, my last position was at the NATO body, and we were preparing for accreditation. We took special care about in processing, about what is expected from our personnel and during the out processing. Of course, we never had an out processing because and as far as I was concerned, nobody left. But you have to have solid procedures about how you will deal with the in-processing of your personnel, what is acceptable and what is not, and for no matter what, you shouldn't fear your personnel, fear your employees, that if they will do something, they will get fired immediately. It's a recipe for disaster if you will do that. There is no blame game in cybersecurity. We should understand that there is no blame game. So if you have solid procedures, and if you been able to communicate that with your personnel, then you are in a very good position in comparison with other companies.
Any other comments? Another problem is, let's say, how do you recognize today's phishing messages or attacks? So we were taught, for example, that you should take a look at the sender, but even today, if these mail servers are misconfigured, so you can actually send emails which look exactly, by manipulating the headers of the emails, which looked exactly like regular ones from email which is the correct one. So it's very difficult for the end users to distinguish between the real mails from fake ones. Also, we were taught, for example, if you visit some web pages and they use HTTPS, they are encrypted and they are secure, so they are fine. Of course, this was misleading because this just means that somebody bought a certificate and that's it. But this was old school. So can anybody comment on this? How to pinpoint, let's say, what is fake and what is not fake in today's environment? Well, because we still have to communicate with clients. We cannot just ignore the communication. Maybe there is some important information which would be then answered.
It's not easy. In my opinion, the best way and the only way is to evaluate the kind of request that is made in the email. The request, and to some extent, the time when the email is delivered. Because usually when the request, the time, and the kind of psychological approach, it's not easy for a standard user. But I see that usually when a simulated phishing campaign has success, it's because it touches certain specific buttons on the user. So the kind of approach and the kind of request are pretty clear. I mean, a user should never be asked to input a password or a single sign-on on a website that was not mentioned in any manual, in any process. Yeah, we go back to the process thing. But at the end of the day, I think that nowadays it's very hard to make sure that an email is phishing just checking the headers. Yeah, what I think is kind of request, psychological approach, and the time of deliver. That's quite fine, and yeah, not 100% safe, but it's still a good approach.
Well, one thing I do is to look if I read something and I see if it makes sense to me. And I will also then look at any link and domain. So you see, maybe it's supposed to be HSBC Bank, so it should be hsbc.co.uk in the UK, but actually it's hspc.something.co.uk. So you can spot immediately that it's wrong. It's the wrong domain. Or you can hover over a link and you're supposed to be dealing with HSBC, but it's going to some completely random string of characters for the link. It's just not, it's been set up by somebody as a phishing attempt. I mean, I'm not an expert on phishing, but for me personally, I hope I don't get caught by one of these, but I do take time to look at emails and try and understand if I think it's real or not. The timing doesn't really work for me because I have customers all over the world. So like yesterday, I was talking to somebody in Honolulu, and earlier I was talking to somebody in India, so completely the opposite sides of the world. So I have to expect emails to arrive at any time. And it's very difficult to understand. And if somebody emailed me from Honolulu, are they really from Honolulu based on the time? They could just be working at 12 o'clock at night. I don't think you can really base it on the time nowadays. Sorry, I'll be quiet and let somebody else have a go.
I think it has become very difficult to distinguish phishing email from standard emails. I think when I create phishing emails or attacks, sometimes I choose particular time frames to do that. So if I target a bank, for instance, maybe I sent the email at 4 o'clock on Friday. So the user don't have much time to interact or ask back their CIO. Or if I kind of have more the attacks in mind of personal devices, I send it on Monday morning before they come to the office with the hope they're on their mobile devices and be less careful with that one. And I mean, all the rest with all these features you can detect, that's sometimes quite true, but also you have homographic domain names like R and N looks like an M. So if you look at your browser, it's indistinguishable, especially you are working, you're not, how can I say, people are not made to look like R and N and M and distinctions of those. So they look there, oh yeah, there's a symbol, and SSL basically just means you have a secure line to your hacker. That's all. But for the rest, for particular phishing, you actually exploit all these things at the time you're sending them. But also I can tell you from a phishing attack, we also gained very valuable information because you can, with some of the phishing tools, you can make complete copies of websites. It maybe takes 15 minutes. You have a perfect copy of that website with the login credentials, so on. So it's very, very hard to distinguish. But when we run on an example now, a phishing attack, we then looked at the results and there's always someone clicking, and that's not bad, that's okay, because we will never have 100% security there. But then we saw the clicks, we can do geolocation, who clicked where on these different areas, and that was quite interesting. Because in the debriefing, we saw, okay, clicks in the US, clicks in China, clicks in North America, that's the headquarter, that's a daughter company, all these things. Oh, there was a click in Thailand. And then kind of, yeah, who the hell clicked in Thailand on one of those phishing emails, right? Because phishing emails get also forwarded sometimes to family, especially if it's a competition for iPhones or iPads and things like that. But then we discussed this and said, yeah, what is there? It must be company. equipment down there. And then the CIO said, yeah, that's my guy. I have a developer in Thailand. And everyone, what? So also from this, you can find really interesting information about the phishing itself. But all these little features are very difficult to detect, and it depends how much you're in a hurry. But maybe email should be charged. You know, we have all this sender policy framework, all this security built in, trust issues, whitelist, blah, 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 domain age, etc. For distinguishing bad or good areas of the internet. But maybe they should cost like 5 cents. You know, and then the end of the year, you will get some money back, and that would maybe stop all this huge mass of phishing emails. Could be an idea. I think that was discussed once as well.
Sozon, your comments?
Yes, I will completely agree with Dominique about how difficult it is, even for us as cybersecurity professionals, to distinguish between legit email and the fraud one. Imagine how a user that he only knows just to click some buttons, and if you will ask something more elaborate, then he immediately will call the IT help. How do I do that? So it's very difficult for the ordinary folk to know exactly how to check the headers and if that's a legitimate site, or I should know that first you have info and after the I have the domain name of the company that I'm expecting the email. So again, I will stick in the human behavior. We should educate our user, our end users, not to be afraid to report it. Use your common sense. If you think that this is not legit, if you have the slightest idea that this is not legit, just report it. It will be much easier for the IT guys, for the cybersecurity teams to deal with that, or report it. Tell, hey guys, maybe I made a mistake. I've clicked that link. Maybe I shouldn't have to, but this will give us the entry point, will give us the timetable, because as already mentioned, the average time for a company to discover that she's been hacked is 6 to 9 months. Imagine what happens with your data in this 6 to 9 months. So for me, it's all about user training. I don't know.
If I may add something to the discussion.
Yeah. Oh, yes. Nikos, yeah.
I am in the opposite side of the river, meaning that I never trust my incoming emails. Never. If I'm expecting something from Sozon, as soon as I get a mail from him, I give him a call or send him a message in Messenger or Viber.
That's
okay,
true.
Was that you? So I'm double checking that people that I know are delivering things to me. And for emails that I have no clue who is it about, I put them in a quarantine folder that I have. And whenever I have the time, I go through them. And to tell you a funny story, I had received an email from DHL. It was a parcel that I had ordered, and it came to me in Greek. So I've never seen DHL sending emails in Greek. So I said, okay, this is surely a spam one or a phishing one. So I never opened up the attachment and anything that had inside the email. So after a couple of days, I got my parcel, I signed for it, and the next 5 minutes, I received another email, again from the same address, in Greek from DHL, saying your package was delivered. So then I discovered that the first email was a legitimate one and not a spam one. So if I had used it, I could change the date of delivery and all that, but I didn't. I know I'm too suspicious with all these things going on.
Sorry, I would like to say something. I don't have the raised hand, so that's why I'm not raising my hand. I don't know why. I would just like to send, I have an experience that people are usually not that suspicious. That's the biggest problem. So they get emails and I will tell you an experience with an incident in Slovenia that they managed to phish a lot of data. Because why? Because they sent people, Slovenian people, English emails with English attachment from people who they don't know, with attachments who they don't know, but still they opened it. A lot of people opened it, and they were told not to do that. So I think the problem here is I don't know how to solve the problem, because nevertheless that people are getting training on that, and they have some procedures. At least in Slovenia, people like to go to bypass some procedures, and that's why they often are a target of such an attack, because they bypass procedures, or they want to do it in let's say 1 second. Yeah, that's if you remember last year, we had this CIO, CIO, yeah, it was the CIO threat, for which the company, which your boss has sent you an email, which was of course not your boss, and then people react to these emails. Why? Because they were afraid. Yeah, it's very urgent. Please do that and that and that and that. And also there were a lot of victims at that time.
Boris, you also raised your hand.
Yeah, thank you. Well, I'd like to comment on a few of the things that had been said here. First of all, Andrei, you mentioned that there are so many misconfigured servers and maybe compromised servers. Yes.
I can tell you from my experience in penetration testing, so 80% of web servers don't check those headers. So, you know, in the email, you have two headers, the real one, which has information about the sender and recipient. And then you have the header in the data, which is shown in the, for example, email client. And those two do not necessarily match. And if there is no spam filter which checks this, then you can make an email which looks exactly the same as the real one. So,
well, you are actually right, because I think you opened like two ways of this thing, because first of all is having the correctly configured servers. Not only those servers that are receiving in terms of being compliant with all the corresponding standards, being really strict in performing the checks on DKIM, SPF. I haven't seen that many companies that are still able to send the DMARC reports, for example, which would help many companies to detect where there is a problem with the spamming from their side or misusing their domain. But on the other hand, also the sending servers. I mean, if you mention that there is a problem to distinguish whether the email really originated from that particular person, well, if you remember the sextortion campaigns, were using exactly the same technique, and the email body said it clearly. If you look on who is sending the email, I am the hacker that is controlling your computer, and the fact that I'm sending you email from your email address is the proof that I'm doing this. So it's sometimes pretty hard for the user to distinguish, but not for the computer. There are, if we do not talk only about the technical standards like SPF, triplets in headers, hello strings, blacklisting, bias, whatsoever, we could rely just on the common check that we are also using. How is possible that the user is sending an email to himself? Yeah, he can use it, but the email will stay within the same context, within the same server. So automatically we are marking this message as a malicious or some sort of problem.
Then you have corporate emails, you know, when there is a problem, when there is a legitimate need that somebody sends an email on behalf of somebody else.
Yep.
And then this can be misused. Well, because this mail automatically allows this kind of email.
Yeah. Another point is what you guys mentioned is what the user is doing, and whether we can train the users properly on not clicking on the link. It's been said here already. I do not remember who said that the people are really trying to be helpful in the emails, trying to really respond as quick as possible. And as Matthias said, during the pandemic, everyone is almost scary of not losing the job. And that's why doing everything possible and trying to fulfill the wish of the potential client or colleague or boss, whoever, not to show the weakness and not losing the job. On yesterday in my presentation, I showed the email. I showed the message that was sent that from the spammer that you have been dismissed from the company. Here is your 2-month salary receipt, and there was a malware inside, obviously. But the thing is, yeah, we are lacking the social contact in our offices where we can ask our colleagues, is this email correct, or is this email just a scam? And maybe another eyes that will look on the email will discover something what we can't see.
Pete, you raised your hand.
Okay, I cannot.
Sorry, I forgot to unmute myself. Yeah, I was just going to say, a couple of people mentioned about, like Dominic mentioned about charging for emails, and Sozan mentioned about discipline and process. You know, I come across this in the Oracle security world when I'm doing security audits of the database, that you find in an organization that each employee has got a desktop account. So they've got a log on, they've got a smart card or whatever to get onto the network, the Windows login. But then within the Oracle database, it's absolutely acceptable for everybody to share all the accounts. So all the DBAs log in as SysDBA, you know, all the developers log in and share one account, end users share accounts and so on. And this seems to be acceptable. And that I always write this up in my report to say that, you know, there needs to be discipline that comes down to the database level, you know, and if you take that as a parallel thing, you know, it's the same thing with phishing. There needs to be some level of discipline. I mean, I don't want you know, to put fear of God into every employee, but if you don't tell people, there is a consequence if they do something without any care whatsoever. They're going to carry on doing it, because that's what happens in the Oracle world. You know, all the DBAs log on all day, every day as SysDBA. It's the equivalent of, you know, everyone on the Unix box logging in as root. And this doesn't occur as much nowadays, from what I see, but it occurs in the Oracle world. You know, it's about policy and process. You need to basically write down what you want people to do, get them to read the policy and agree it and sign it off and say, yes, we're going to do that. And there needs to be some consequence. Whether you use the consequence is up to you, but you should put something in place that makes people take this stuff seriously. You know, and I talk about this in the Oracle world, and I can see a parallel that you can easily do this in the phishing world. You know, and the final part is training. That, you know, I suggest there should be training on certain aspects of doing something security-wise in an Oracle database. I can see that there should be training for staff in terms of phishing. But I think, you know, it's about discipline, policy, a consequence if you don't take, you know, the right action. You don't have to use it. You don't have to sack anybody or do anything to them, but there needs to be that slight fear there that they need to take a bit more care when they're doing something, I think. Thank you.
Yeah. Marco, you wanted to comment on?
No, sorry. Oh. I just want, no, yeah. Thank you. Sorry, I don't have the raise hand symbol. I don't know why in my Zoom, so I cannot raise the hand. Yeah. It seems like something is so wrong, but okay, sorry for that.
So to make things more funny, so I will try to share one movie from YouTube, probably well known, but maybe not for all the participants. And then we can comment it on the importance of the education of people and how to defend against phishing attacks. Just a moment. I will try to. Okay. Okay, I will try to share it now.
A lot about cybersecurity lately, largely because of what happened to Sony. Companies and individuals are more concerned about the safety and privacy of their information than ever. President Obama has unveiled a number of new proposals this week to crack down on hackers, and he plans to address this in the State of the Union speech on Tuesday. And it's great that the government is working on this, but the truth of the matter is we need to do a better job of protecting ourselves. You know, the most popular password in the United States is password 123. And as long as that's the case, we're vulnerable. So Today, we sent a camera out on a Hollywood Boulevard to help people by asking them to tell us their password. And this is how that went.
We're talking about cybersecurity today and how safe people's passwords are. What is one of your online passwords currently?
It is my dog's name and the year I graduated from high school.
Oh, what kind of dog do you have?
I have a Chihuahua Papillon.
And what's its name?
Jameson.
Jameson. And where'd you go to school?
I went to school back in Greensburg, Pennsylvania.
What school?
Hempfield Area Senior High School.
Oh, when did you graduate?
In 2009.
Oh, great.
It's like my cat's name and then just like a random number.
Okay. Have you had this cat for a while?
Yeah, she's my childhood pet.
Aw. And what's her name?
Her name is Jolie.
Jolie. So like a password of yours would be Jolie and then a number.
Yeah.
Like number 1?
Like my birthday.
Oh, when is your birthday?
June 12th.
Oh, nice. And what year were you born?
95.
Oh, great. So Jolie, 6/12/95.
Yes.
Got it.
So you mean to give my password right now? No, I cannot do that.
But we all want to know what it is so we can tell you if it's strong or not.
Oh my goodness. Let me think. Okay, one is Tel Aviv. Yeah. 468, and then Israel. It's only 3, but it's, you know, it's for me it's strong enough.
Ireland 1 2 3 4. Gemma 1 2 3. Spelled Gemma.
Well, most of them are Italian.
Oh, beautiful.
Yeah.
Like
so
what?
like
what's a good Italian password?
my grandma's name.
What's your grandma's name?
Maria.
Maria. So Maria is your password?
Oh yeah, now you know my password. Oh yeah.
Yeah. Well, the important thing is they learned a terrible lesson. Hi, I'm Jimmy Kimmel. Did you know there are things other than pornography on the internet? Watch them on the Jimmy Kimmel Live YouTube.
So, why does this work still today? And how do you educate people so that they don't repeat such mistakes?
If I go, I think there will always be people clicking on emails, right? So, and if you do phishing attacks, it's not when you just click or open attachment you get into problems. So even if you make a preview of an email, I already can get information about your machine, your operating system, etc. So, and with phishing, you always get click rates. Click rate is not the best KPI so far, but between 10 and 30% always, depending on the phishing email you create. So I think it will always be here, phishing. It's not something you can eradicate completely. And it should be okay. You need to find technical solutions to help people do that, which is, of course, awareness, educate them. And basically, we had that before, like Boris mentioned it and Sozon, like you should have your personal CISO right next to you. So the CISO, he's right here. I don't know, you can click a button, it will send the phishing email. You can click a button, you will be connected with the virtual CISO or whatever, and then you get help. Something like this maybe needs to happen.
I wanted to stress also that education or the phishing attacks tests are just one of the steps you can take to increase the security. So it's not the only solution. So you need another technical solution. So awareness is not enough. No? Pete? Any comments?
Yeah, actually, for instance, if you see phishing for, I'm sorry, I cannot raise my hand. That's why I'm just speaking. If you see phishing mails which fish for credentials, a good technical solutions to counter this is not to prevent phishing because you cannot do it, but you do two-factor authentication, for instance, yeah. So that even if somebody gets your username and password, they are not able to log in into your account, for instance, yeah. That's just an example. It's not the holy grail of phishing, how to prevent phishing, but at the end, as my predecessor said, I think we will always have a number of people who will click on the email. If you have, I don't know, if you target 100,000 people, then of course some people will click.
Yeah, I was just going to say to Dominic, who said about technical solutions. I mean, I'm not familiar with everything in phishing in terms of what products and so on are out there. Are there any AI solutions that can be used to detect and parse emails to see if they're possibly phishing emails?
There are AI solutions, but they're getting used for deepfakes to frauding and making CEO fraud, for instance. So technology will work both ways.
So they're using the AI to actually create. Okay.
And mimic your voice and your face. So, and actually it worked. Last year was the first proof of concept of obtaining money, CEO fraud based on deepfake. It's amazing. So
One comment also from my side, a lot of solutions today also do link rewrites, so the link maybe in the email actually points to some sandbox, which is used for, let's say, testing whether it is some malicious site link attachment or not. However, this sometimes also represents a problem because the link does not look like, let's say, a trusted source anymore. So it's not from the company you expect to be. So it's a two-way, let's say, trust, and then you might have some problems trusting these links, even in the legitimate mails. Not every solution, I think, it's it's good for, let's say, preventing any kind of phishing attacks. So it can also, let's say, make mistrust between these services. I don't know who is next. So maybe Boris.
Well, there are, as you said, for example, with the links, there is one particular problem. And when you mentioned the AI, you guys better think about the fact that the spammers are using the AI against us. They are using it.
Definitely.
So if we think that we will, for example, block all the phishing attempts by enabling multi-factor authentication, we are wrong. I witnessed like last month at least 2 cases on a different clients that enabled the multi-factor authentication because they were using the O365 online version, and at the very moment when they enabled the multi-factor authentication, the behavior of the spammers and the phishers changed. As Marco mentioned before, we see a lot of spear phishing these days. This is not anymore like a huge wave of really, we will phish everyone. This is a spear phishing, and the CEOs or the managers that were the target immediately got the message. Instead of enter your login details, it was like you have to verify your code again for the application. So this is happening. Another thing is when you said something about rewriting the links, this is not going to work pretty well, in my opinion. And the fact is that there is a simple way around sending an HTML attachment. If you send an HTML attachment, it will be not rewritten at all. And all the links and all the active content that is inside of the HTML will be executed in user's browser. And we are still on the where we've been before. So that's my comment. Thank you.
Matteo?
I would like to go back for a moment to the video we just saw, because in my opinion, I think it's very significant. Because it shows, once again, how easy is using the right words to influence people's mind. I mean, no one will probably tell their password if they ask it directly. But what we saw is exactly what's happening even in the emails or in every other such engineering interaction. So probably that's the root problem. We saw clearly that when the interviewer started asking people questions about themselves and making them feel comfortable, they started answering about everything. And that's exactly what happens even with the message. So of course, it's possible to educate people, to teach them, but this kind of trust, this kind of behaviors are not possible to eradicate, in my opinion. So yeah, we need the technical solutions, but at the same time, when we talk about artificial intelligence or very sophisticated systems, we cannot forget that to teach these systems how to work, we need a clear environment, and that's pretty hard to obtain. So probably the best solution is still having some kind of layer, and yeah, try to give people some sensibility and sensitivity, but never forget that they are humans, and that at the end of the day, if only one of them will fail, the attack will have success. So the situation is very not balanced, because who's defending have to think about 1,000 things, while the attacker can use one single vulnerability. So yeah, the video was very, very interesting, and I never saw it. Thank you for showing it.
Very fun, yeah.
Yeah. Yeah.
Sozon?
Yes, I would like, first of all, I would like to share a bit the screen. I found this email. I don't know if everybody can see it. You can see here in the round circle that it says no does reply from Amazon.com. So if we are asking for an end user to understand that this is not a legitimate answer, then we are asking too much. So for me,
this is the problem I mentioned about this
exactly, Andrei.
Text,
So we need to educate, and we need to have technical and administrative controls, because we are discussing up until now that everybody is at his job, so we can implement all these processes and all these technical details. But at least for the pandemic period, people is working from his homes, and maybe this will continue. We can't be sure what's happening in his house, and I don't know if we are able to enforce some controls due to the GDPR, or I don't know what other legislation may be in place in other countries. So we need to create a cyber-oriented culture in every aspect of his life, because if he will be in his house and he will use the corporate laptop to check his emails because it's better than he already has, and he will click in that phishing email or that phishing URL, and then this laptop will be introduced in the corporate network, then you will have a problem. So this should be a holistic approach, not only when we are in the job, not only if we are under the firewalls and the wall and the perimeter that we create in our companies. We need to extend that in every aspect of our lives. So yes, it's difficult. I think Matteo said that if we have only one user, if he will click, then we have a problem. It's 1 point failure for all the system. And we should also be prepared for the breach. We should act like we are already breached. We have to assume that one person, one user will ultimately click that mail because maybe the hacker had gone the extra mile and create a very legit email.
So it's important that we have technical solutions, also, let's say, network design implemented in such a way that the damage which is caused by a single user is minimized.
Yes,
so
of course.
The one user cannot, let's say, the company down.
Building, yeah. Burn down the house. Exactly, yeah.
Pete,
Yeah, I mean, just Matteo mentioned the video, the Jimmy Kimmel video. I've seen it before, but it reminded me, and then I forgot. And when they mentioned it again, it came back to my mind. There was one by Kevin Mitnick, who calls himself the world's most famous hacker, but he's an expert on social engineering. And he's in the sort of foyer of some conference and goes up to some woman and said, with your permission, I'll gain access to your online banking. And I don't remember what he did, maybe transferred some money or whatever, I can't remember. And he gets a tape recorder out with a baby playing on it, and he keeps moving it backwards and forwards. And he rings up the woman's online banking, and he's saying how, oh yeah, you got to help me out. Our wife's gone out and I'm left holding the baby, and I need to get this sorted out because she's going to kill me if I don't move this money. And the person at the bank did it. They did what I don't remember exactly what his attack was. I'd have to go and find the video again, but it was very clever. It's not phishing, it's social engineering, but obviously it's very, very similar to the same technique. But thank you for Matteo because he reminded me of that. I'll go and look for that later and watch that again. Thank you.
Boris, you raised your hand, or is this from before? I don't know.
I will just quickly thank Sazon for his contribution, because he said something again about the education, but the education and cyber culture needs to be raised in our kids, starting from the very little kids. And I mean, during this pandemic, if you take a look what the kids are actually doing at home, because sometimes they can't go to schools, means that, well, yeah, mobile phone in my hand, and here we go. Watching what? Doing what? We have no idea. And this is what we have to stress. And this is not only the task of the schools, this is also the task also us as a parents, for example. And the culture needs to be like, the culture needs to be enforced on every single step. Yet we see like in Europe, we see a completely different approach. It's a country per country. There is no coordinated approach. Even we have ENISA, for example, there is no coordinated approach. And if you take a look, for example, on a campaign that are here in the Czech Republic, they are completely different and aimed on a different topics, as for example in Germany. Thank you.
May I just add to this, Boris? I think what you said is very interesting, no coordinated approach. If you talk like now with cyber philosophy, I mean, everyone is using the same products, you know, same firewalls, same intrusion detection, but the banks I work for, they have everything, most expensive stuff, they still get hacked. So how can we have this variety if people are using the same products and some are safe and some are not? I think that's also one interesting aspect. And the other one is actually the misuse of data, misuse of media and data. Email is just email. Email was not meant to be for sending around contracts with signatures in it. So people are actually misusing the media for something which is not, or sending password resets through WhatsApp Messenger, or, you know, all these things. So that is a big problem. And the other one, which is worrying me at the moment, is the business is going through predictive maintenance and other means going to big data. So the CIO is talking about data lakes, and they think it's wonderful, tap into all this data they collect. And I think I can make a somersault backwards if I just hear this, because if you compromise this big lake, all your data is in jeopardy. So from a security perspective, you're talking about segregation, compartmentalization, etc. And CIO is talking about big data and data lakes. So that's completely the opposite. And still, from an InfoSec perspective, you and we and everyone needs to protect this. So that's also some of the factors, I think, contributing to the problem here.
Sazon?
Yes, I would like to take a sentence from Boris when he told about how we should start educating our kids. I couldn't agree more. One personal experience here in Greece, the previous decades, we had a very big problem regarding traffic accidents. We were like in a little war. We were losing almost a small town every year. And then the government decided that it's time for driving education from the preschool. And I remember that we have lectures, that we have people from police coming in and discussing and so on, what we should do wrong, how we should behave, because it wasn't a matter of cars or road conditions. It was a matter of behavior. So I couldn't agree more with Boris that we should start thinking and we start moving towards a training schedule, training programs in the schools from the beginning, because I see now kids around 5 or 6 being with a tablet or a smartphone roaming freely in the web without any restriction, without any concern, and yet we wonder why we have all these problems. Yeah, so yes, I totally agree with that approach.
Just one comment also related to all this discussion and to the education. My belief is that we always have to educate users on worst case scenarios. So we should not assume that the technical solutions will solve the problem. So this is an additional, of course, security control. But when we do this education, and also when we do, let's say, practical phishing attacks testing, so these scenarios should be worst case scenarios. So even I think it's acceptable so that you turn off some of the security features you have, so to make the scenarios harder for end users. So this additional security feature you have in practice, maybe it will stop this kind of attacks. But then, of course, maybe in some future time it will not work, and the end users should be ready for this. So, any comments on this? What you do? Because also in schools, when we do the tests, when we let's say learn, we learn usually more. We teach more material than it is on the test at the end, you know. So, yeah. Pete, maybe.
Yeah, thank you. I was just going to say that it's a good point that if you have so much security preventing something, people become complacent and they rely on the security. They don't. They then forget about the basics and actually understanding something. So then when that security is breached and is no longer good enough, then you're back to the same problem again, and no education and no literacy on how to actually deal with the particular type of problem. So adding security could actually be a problem if it then in the future breaks down, which potentially it will, because attackers are always going to find a way around it. Yeah, thank you.
Susan?
Maybe I could just add here. So it's about cyber maturity. So if we have cars, in the past, they weren't safe. Then we had ABS systems, and mostly legislation or regulation is changing if there's something terrible is happening. Terrible accident, oh, then there were ABS brakes, or we had the seat belts, or all this stuff. And now we have regulation. I have to go to check my car, I don't know, every 3 years. When it's bought, it has to be checked in a perfect condition. If there is a brake problem, they call their cars back. But with software, there's nothing, you know. Anyone can develop some piece of software without or with specific quality control, without security in it or not. So I think this is in the basis of the industry, and from a trust perspective, very bad. It's useless. And then if you combine this type of software with planes, for instance, and we saw that software kills people. We saw that, the two examples. If you put this software in planes, in cars, in machines, in submarines, whatever, then we have this particular problem. But probably we need to solve the software problem first and tell them these are the quality standards. This is the minimum for password length or whatever, and should test actually the software. So it's ready for humanity. It's not the problem of the kids, because they use what's available. But we as, I don't know, industry need to make sure that the software is secure for them to use.
There are some steps towards this. So there is already accepted the Cybersecurity Act in Europe, you know, which expects some kind of certification for IT products. Of course, it's still not obligatory, you know, it's just on the basis of companies whether they want to certificate their products or not. But I think it's a correct step forward. But I agree, so it's not like, let's say, when you want to sell a refrigerator, somebody has to confirm that it is safe to use, but not for the software product, you know. Yeah. Susan? Yeah.
Yes, exactly. I have to say that I agree with Dominic We have to create better products. We have to educate our people. We have to implement better controls. I believe that we are still in the beginning, in the very beginning. We are dealing with the child problems of cyberspace. I believe that today the technology is advancing in the rhythms that are unprecedented. We have the cars from the first car until now that we are almost creating self-driving cars past around 100 or 150 years. The aviation, the same, but in the computers, I remember 30 years ago, the computers were very, very different than what we have today. So it seems to me that technology is gaining on us, and we have either to limit how we are creating new products, limit the rate of how we invent things, or try to keep up with what we are inventing. Because it seems to me that we are inventing without thinking about the consequences or thinking about how we will actually use that technology that we're creating. So yes, we have to take a holistic approach. It's not a one trade-off. We won't create, at least for the next years, we won't create a computer that will be bulletproof, that will be fully fail-safe. So everything should be implemented. We have to start thinking about cybersecurity very, very seriously, from government level downwards.
So to conclude, Boris, so your last opportunity, and then we have to wrap up the conference.
Thank you. Well, I have to agree with Sazon. Yes, we have to think about how to make the cybersecurity better. One comment from the chat is using security by design. Well, that might work unless we will not do all the products with the aim of selling them and having money out of them. So that's the basic problem. We have a lot of products that are made with the lesser price as possible and the least price as possible. And that's why it lacks the cybersecurity. But regarding the testing of the phishing still, and so it's like, again, economy. What is the win-win situation in a phishing testing? The win is that the users will respond correctly. And what happened then in a real life? I experienced the situation when the company didn't want to spend a few €100 for a simple phishing test just because they said, we do not see the economics on this. That's the problem. So unless we will see really the economics, unless we will not have like a cheap products and we'll go really for security by design, as been said in a chat, yeah, this might happen. But I don't think this will happen because there is a huge pressure from the products that come from many countries, unsecured, and there is no security by design, but low price. Thank you.
So thank you also to all the speakers of the round table, and I am giving the word now to Masha to finish the conference.
Thank you, Andrei. So thank you to all participants of the round table. So that's it. We came to the end of the hacking conference. So thanks again to all speakers, to all participants, to our sponsors, and of course to our moderator, Andrei. Thank you very much.
Thank you.
So I would like to invite you to our biggest InfoSecurity conference, InfoSec. I believe we will meet in person in Nova Gorica from 2nd to 4th of June this year. So today is Friday. I wish you a nice weekend. The weather will be sunny, so enjoy as you can. So thanks again, and see you in Nova Gorica in June. Bye.